everyone can hear me, right? That wasn't just me who couldn't hear Jonathan.
I hear you.
So when you heard him, I wonder why I didn't hear him. 1 second.
Can you hear me now?
Are one of you able to please mute and then see if I can hear you? Because I don't understand why everyone can hear him but me.
I should.
1 second. I think I realized what the problem was. Hold on. Okay, there we go. Fixed. Sorry about
I,
that, Jonathan. I couldn't hear you.
that's okay. Now you can hear me, Aaron?
Now I can hear you. I had my speaker driver set to a different speaker, not the one that needed to be. Okay, now I hear.
No problem. I just wanted to make the point that I didn't know if you planned on having students present their Python projects or not.
Okay.
What's the answer to that?
The plan was to ask next week. So far, I think only 3 people have submitted. I would like to arrange with people who want to, like when everyone has submitted, to do that next week. But so far, we only have 3 because some people, a lot of that people asked me for extensions because it's
Okay.
a longer project. So the plan
Yeah.
is yes, next week.
Okay. My comment is just the following, and I'm speaking to the students. Presenting your project is a really important skill unto itself. A person could be like a geek and be able to program cool stuff, but if they can't talk about it and explain it to other people, that's a chisaron. That's a deficiency in their professional persona. So part of your excellence as a young professional is not only doing stuff, but then presenting it to the other people on your team. So I strongly recommend, and even though it's not easy, I recognize that, and a lot of people don't like, talking in front of a group, but it's a very valuable professional skill, especially really in the field of cyber, because cyber experts are they're in high demand, and there are very few of us. So you're always explaining things to other people who are less technical, whatever. So in this group, you're, let's say, all technical, whatever. But the point is, putting up on the screen your project and explaining what it does and how it does it is really important skill. Not to mention that you may even want to add it to your professional portfolio and attach it to your LinkedIn, and even you can record your presentation and have that and share it with others. So I strongly recommend for anybody to make the extra effort to present their project to the class, because that in itself is a valuable skill. So that's what I wanted to say.
Thank you. I would just second that and say from experience, I worked in a few companies, and I worked with a few different clients of companies of like my employer. And I would say one thing that differentiates, I don't know how to say this, it sets them out. It makes them special. Miyuchad in Hebrew, the word would be. It makes them distinct. Is that in larger companies, specifically, I don't want to say names. I don't know if I can say names, but in larger, successful, very professional companies that I've worked with or dealt with their people, they are very good at communicating things. Even the developers, who are, let's say geeky, right? They're very technical. They build things all day long, but they are very good at communication. And like when we have a meeting with them, the meeting is like, here's your 15 minutes scheduled, chick chock. What's the issue? Here's what I expect. Here's what's doing. Here's what's not doing. Here's the effect. Here's the mitigation. Done. And that is a skill that I see more in like larger companies that have a larger talent pool and can afford to pay for better people. Whereas in like some other like I don't know, homegrown like mom and pop type companies that I've dealt with here in Israel, where they're not so professional, they don't hire the best people necessarily. They can't afford to pay the highest salaries. I've seen communication has been lacking. It's not that the skill has been lacking. It could be the developers are great. But one thing that I've actually noticed in working with like international big companies is communication is really in demand. And especially because everyone here speaks English. That's also a very good skill too. So yeah, okay. So building on that, so what's it called? If so far I think we have 4 submissions. A few people asked me if they can have an extension, which I'm fine with, as long as you're, taking the time. So over this coming week, if you'd like to present, please message me on Slack. I would love to schedule that in. If no one messages me, then I guess we'll have to, I don't know, pick out of a hat or something. But my hope is that someone will, a few people will want to present, maybe like, I don't know, maybe like 20-minute time slots, something like that should be enough. Maybe even less, depends what your project does. But yeah, let's do that next week. And I think that's a great opportunity for everyone. All right, so let's start with no homework. So let's start with the slides. Jump on in.
Quick question. Are we able to be given tips or even like a presentation from a previous cohort that we could, I guess, watch or
I'll share some. I'll share some in the Slack today.
Okay, thanks.
Sure.
I was also wondering if maybe we could have some feedback on our project before deciding to present it.
Perfect. Okay. I didn't see who spoke. Did you submit yet?
Yes.
Okay, so then I'll look over here. I think that I have 3 or 4. I'll look over them. All right, I'm putting the slides in Slack now. Okay, slides are in Slack, and let's get going. Okay, so we are done with Python. We are done with scripting. PowerShell and Linux and Python. That is all important, but with that, we are finished that segment of the class, and now we're going to head into the next segment, which is going to talk about information security, InfoSec, and specifically, we're going to start with an introduction to web and how does the web work? What protocols are behind the web? What happens behind the scenes when you click on a website and you click on a button? What's going on? And we're going to get into that. All right, so now so till now, you have spoken about networking and operating systems and virtualization. I was not here for that. Scripting, we saw with Python and some Linux. And now, like I said, we're going to get into web. Now, web, I don't know if you're familiar, is based on HTTP and HTTPS. You can see that just by going to your browser. And 1 second, my computer is freezing. I have a lot of things running. Let me close them. Hold on. There we go. Let me just close some running things over here. That. And let's close that too. Okay, there we go. So now you can see what is HTTP just by going into your browser, right? We have HTTP, google.com, right? Now, when I go there, it's going to go to google.com. And now here you notice it says HTTPS. So we're going to speak about what is HTTP, what is HTTPS, and that's the fundamentals of web protocol. And then we're going to speak about some other web domains, such as domain names, what are cookies, what are sessions. We're going to speak about headers and requests and packets. And then we're going to speak about some cloud stuff too. So that's the plan for today. And yeah, let's jump right in. All right, the internet is becoming the town square for the global village of tomorrow. So that's from Bill Gates. Elon Musk said some type of quote similar to that when he bought Twitter, that he wants to preserve the town square, and that's why he bought Twitter, because he wanted it for free speech, for better or for worse. But yeah, the internet is basically, it connects everyone. It connects every single person across the entire globe. And you can be sitting in who knows where, and you can connect instantaneously with someone 10,000 miles away. It becomes the town square of the world. And that's the quote from Bill Gates. Now, some background is the internet is, well, when we speak about the internet, what is the internet? We're familiar with emails, we're familiar with, I don't know, WhatsApp, we're familiar with websites, right? Essentially what that is a bunch of servers that are connected around the world that send data. Sort of like this picture on the side. You have a bunch of servers all over the world, and those servers serve data. What does it mean to serve data? The internet is basically sort of like a mashal, to compare it. It's sort of like a cafe. It's like a waiter comes over and says, what would you like? And you say, well, I want a coffee. So the waiter goes back to the kitchen and says, okay, he wants a coffee. Kitchen makes him a coffee, waiter brings it back. That's essentially the way this works. The server is going to be the waiter is going back and forth, and you are the clients. You're buying a coffee, you want to go to a website, you want to send an email. So the server responds with, okay, here's your website, here's your coffee. That's essentially how the web works, the World Wide Web, as they called it like 20 years ago. It's millions of devices, probably even at some point we'll get to billions of devices. I don't know how many devices we'll get to, but there's millions, if not hundreds of millions, if not probably billions of devices connected. And there's services that are available over the website of the web. And there's 3 examples that we list over here, which is www, which is usually websites. FTP is another protocol. FTP is a protocol for file transfer protocol. I don't know if maybe you covered it when you did some Windows and Linux. Maybe you touched on it. Yeah, you know, yeah, anyone? If you touched on FTP?
I don't think so.
No? Okay, so FTP is a protocol, and we're going to speak about protocols later, but it is, and we'll define it more, but it is a protocol for transferring files. I can have 2 computers. One computer hosts an FTP server, and the other one hosts an FTP client, and they connect and they talk to each other. That doesn't happen on the HTTP protocol like we saw in here. It doesn't happen over using this protocol. It happens over FTP, but they both use the internet. Email is the same thing. There's protocols for sending emails called POP, POP3, IMAP. Those are protocols that are specifically designed to talk to email servers. Right? If we take our mushel of going to a cafe and ordering a coffee, right? So we understand that if I want to order sushi, then I don't go to the same place as I bought my coffee from, right? Because there's different types of kitchens. There's a kitchen who makes, sushi. It's gonna have someone who knows how to make sushi, and then I can go to Starbucks and that will make me coffee, right? So it's the same thing like the internet. There's servers that handle FTP protocol, which is for file transfer again. And there's servers that handle email, which is the email protocol. And there's servers that handle websites called web servers. So I think that mushel is sort of a, I think it's a good way of basically understanding the difference between protocols and the difference between types of servers. So now www is what we're all familiar with from typing in websites. And it was created way back when, I don't even know, like 40 years ago, a very long time ago, a very kilo, but a long time ago. And it works, like we said, on the HTTP protocol, which stands for Hypertext Transport Protocol, because it is essentially transporting text between your browser, which is displaying text, right? Like this is text, and a server. There's 2 different versions, which is version 1.1 and 2. Not really so many differences between them. Not super important what the difference is between them. Practically, it's the same thing. If you go into web penetration testing, then there will be some differences, but like they're very niche cases, and 99% of the time, version 1.1 and 2 are basically the same for our needs. All right. Okay, so now, speaking about the fundamentals, because we're going to start from the basics. So I don't know where everyone is familiar with this. If you've ever written any HTML before, if you know what a server is, if you know what the word backend and front end means. So let's explain this basically from scratch. We have a URL. The URL is right over here. Let me get my pointer. This is a URL. You type in some words, google.com, somatcounseling.com, some words, okay? That's called the URL. A URL stands for Universal Resource Locator. What does that mean? It's universal. I mean, it's applicable to the entire world, and it is a resource locator. It locates resources. So the resource that I want to locate is a website. I want to go to this website. Now, what if there would be, a few different people in a few different countries that all decided to make companies and websites called somatcounseling.com? Well, that'll be very confusing because I don't know which one I'm getting to. Am I getting to the one that's located in Israel? Or am I getting to the one that's located in Uganda? So now I'm confused. So therefore, we understand that URLs have to be universal. There's only one somatcounseling.com in the entire world. No one else can make this domain, and no one else can make a website with this URL. The same thing with Google, right? Imagine there could be Gmail, which is Google, and then there could be gmail.com, which is like, I don't know, a hacker's version, right? That would be really confusing and bad. So URLs are universal resource locators. There only exists one instance of it in the entire universe. And its function is to locate a resource. In this case, a website. It's the same thing as an address. I want to send you a piece of mail. There's only one place in the world that has, 111 South Broadway Street, New York, whatever the zip code is, I don't know. There's only one place in the world with that, right? That is universal. So now, once we understand the URL, this is just getting to the page. But what forms this page? How is this page being built? What's behind this page? So in this, we have to differentiate between clients, which you see down here, and servers. Clients and servers, again, going back to my mashal with the cafe, the client is the customer. It's who is accessing the data, who is coming into the cafe and saying, hey, I want a coffee. I want to go to somatcounseling.com. That's the client. And that could be mobile, like little Android logo. That could be web, like on a computer, so you have Chrome. And that could even be command line, right? If you're familiar with curling things, I don't know if you are, but I can curl something, right? Like by going like this. Actually, let's actually use somatcounseling.com as an example. Counseling.com. Okay, a lot of images here. There we go. So I just browsed to the website from my command line, right? So I'm getting some content that's on the website. Let's see if we recognize anything or not so much. Let's actually try again. Looks like I just got the headers. Okay, so we see some information. It's built with Wix. And let's see what else do we see over here. Yeah, static Wix site. And we see, okay, this is how long it is. Okay, we see some information. We see it's using HTTP 1.1, right? Not 2.0, it's 1.1. Okay, so we see some information about the website. What do? I just browsed to the website using my command line. So my command line was a client, right? So these are the different types of clients. We could have a command line, regular web, or we could have mobile. And now we have servers. So the server is going to be returning data to me, right? So the server said, okay, you're going to somatcounseling.com. Well, here's how it should look with this image, with these words over here. the server provided that back to my browser, and my browser displays it to me. There's lots of different types of servers. I don't know, probably dozens of them. Two of the most common that you're going to see are called Apache. Apache is an open source, they're all open source, but the Apache server is really commonly used. And this Nginx, it's not Nginx, it's Nginx. That's the way it's pronounced. Nginx is also a very commonly used server. That's technically a proxy, but we don't have to get into that now. Let's just call it a server. Those are going to be probably the two most commonly used servers, are Apache and Nginx. But there's others, there's dozens of others. And then we have another layer. We have, let's say, Wix. So what's Wix? Wix is how we built this site, right? This site is built with Wix. Has anyone here ever made a Wix site? Pretty common, pretty easy. Maybe you made, I don't know, you sell something online, or I don't know. I've made a few Wix websites for random things. It's free, it's fun. No, all right. So Wix is the platform that you use to build this, because when you take this website and you break it down, it's all a bunch of code that looks like this. HTML, body, form, action, post, lots and lots and lots of ugly and repetitive HTML. When you want to build that, you don't actually type all this stuff over and over again. Like maybe 20 years ago you did, but today we have platforms like Wix, and Wix will do this for you. You can drag and drop things, and then the code is already built in. Coding today, obviously they're still coding, they're still web designers, but the amount of code that web designers actually type repetitively and manually has gone down, because a lot of it is frameworks like Wix or like other frameworks that already have the pre-generated code built for you. So now let's actually just go to this site and let's actually just see what's actually going on in this site. So I'm going to bring this up 1 second. Okay. SummitCounseling.com. I spelled that right. Okay. So now we browse to the site, right? So that means that I requested something from the server. I said, hey, I want to go to Summit Counseling, and the server said, okay, here it is, and it gave it to me. Now, I mentioned, I think last week or a few weeks ago, that there's a cool extension called Wappalyzer that allows you to see a lot of information about a website that you're visiting. So just by opening Wappalyzer, you can install it. I mean, it's available in Chrome or Firefox or anything. It's an extension, it's a browser extension. And I can see, okay, so CMS is Content Management System. It's using Wix for that. Some other information, let's see, it's using HTTP 3, right? We spoke about 1.1 and 2 and 3. Again, not really so important, like from a, it doesn't really make that much of a difference unless like you're debugging something, but usually we don't really care that much, but okay, it's nice to know it's using HTTP 3. Let's see, we have some JavaScript libraries. We'll get into JavaScript later on, what that does. We see it's built on Google Cloud. Okay, so there's Google Cloud in the back end somewhere doing something. And we see some security things. And okay, so some basic information. We see it's using Google Cloud as a CDN. So the server that is running this is actually a Google server. It's not Apache or it's not Nginx. It's actually a Google CDN. A CDN is a content delivery network. It's basically servers around the globe that are close to you and can provide data to you very quickly. So like if I own a server, right, my server is going to be in Israel, and then you're accessing my website from Australia. So then the data is going to have to travel like 10,000 miles, and that's going to take a few seconds to load. And if every time you click something on my site, it takes another 3 seconds, well, that can actually add up, because if you're shopping, or I have a lot of products, and every product is another 3 seconds to load, that would be pretty annoying. You'd probably not shop on my site. But I could use Google Cloud CDN, which is Google has a content distribution network that is spread globally. So Google has servers in every region in the world. The same with Amazon, the same with Microsoft Azure, all the large companies have this. And that means that if you're in Australia, well, my website will be stored in Australia and in Israel. And if you're in New York, so it'll be in New York too. It'll be distributed around to all of Google servers. That's the content distribution network. So that's the server that I'm getting this data from, a CDN. Now, if we want to speak about HTML, so let's, and you can do this in your browser. Maybe some of you have seen this before, maybe not. Open any browser, it's all the same, right click, and then inspect. There's different hotkeys. In Firefox, looks like it's Q. In, I think, Chrome, it's Shift-I. But you can inspect the website, right? Now this, all of this is the code that's running on this website. And, you know, it looks like a lot of code, and you can even open these up more. And yeah, there's a lot of things going on this website. But just to see what is going on. So this is what's going on. Now, we're not trying to be web developers here, so not every single thing is important, but you can find something cool. For example, if you click over here on this left thing, right? And now, actually, let me get rid of my little pointer, 1 second. Mouse. All right, so I'm going to click on this little left thing over here. And now I'm going to click on the word, I don't know, home. So now, do you see this right over here? Home. That is this, right? Every word, every element, everything here is referenced in the code. So if I select, how about us? So that's down here. We see the word about, and I can see some information about it. I can see that they're using the font family Lulo Clean W01, and it's bold and sans serif. Okay, information about it. That's the word about. And then over here is going to be the word us. Okay, so everything in this website is in this code. And this is the code that gets returned from the server. Now, when my browser client requests it, my browser says, hey, I want to go here. The server passes back this, all of this code. That's what the server gives back. The browser then knows how to take this code and make a website that looks normal to us. So that's the browser. That's actually Firefox itself that's doing that, because the server just passes back the code, and then Firefox makes it look like something. So okay, that's the understanding, the fundamental understanding of clients, servers, and what data they're passing back and forth between them. Any questions on that? Is that clear? Is there any other points you want me to, any questions or any other points to reiterate?
Yeah, how do the servers make sure that they're not duplicating URLs?
So, very good question. There is, are you familiar? So again, I'm just gonna repeat the question. What makes it, tell me this you're asking, what makes it that I can't register another somacounseling.com, right? And then there'll be 2 somacounseling.coms.
Yeah.
Is there something that's keeping the servers in sync? Like if my server in America and the other server in Australia, what happens if each server is going to have a different somacounseling.com? So the answer is, this is where global DNS comes in. DNS, did you speak about that before?
Yeah.
Okay, so you're familiar with what DNS is. DNS is the correlation between names, right? We have, oops, I don't want that guy, I want this. There we go. Right, names and IPs. So 1.2.3, right? This is DNS. Now, that DNS is shared globally by the entire web. Because if it wasn't, then we wouldn't be able to have a web. Because then exactly like you're saying, one website in one country would mean something totally different. Not even a country. We could be in the same room but I'm talking to one server and that directs me to a different website, and you're talking to a different server and that directs you to a different website. So the concept of DNS, correlating names to IP addresses, is a global directory. Every server, every browser, every internet provider, everyone has access to DNS. Therefore, because it's globally accessible by everyone, and we're all connected to the same thing, so then that means that if I'm registering somightcounseling.com and I'm sitting in Hawaii, well, then that will, the word is called propagate, that will propagate to all DNS servers around the world. They will all know someone in Hawaii just registered somightcounseling.com. We're going to remove that from our list of available sites. And then you will no longer be able to buy it or register it on one of the other sites. Therefore, because it's a global list, that's why we don't have any duplicates. Does that answer the question?
I guess so, but how does it become a global list? Like,
Where is it
how
being
come let's say
stored?
Wix can't force, I don't know, Apache can't force like Nginx to say, forget, you can't use this because whatever, I don't want you to. Like, what if they were like in a fight almost with each other and they wanted to let two websites, what's it called?
Right.
I mean, maybe I'm just like asking a question is a little bit too much for like the general flow of the
No.
class. but-
No. I hear. That's a good question. In general, I think the way the architecture is that it's sort of distributed globally. That means that no one person owns the internet. So it's not like Wix. Okay, let's say Wix. If I own a site with Wix, right? So I bought somightcounseling.com and I bought it from Wix, right? So I bought it, but I bought it through them. And then they don't like me, right? So they could take that away from me, right? Because I bought it through them. But the way the internet works is it's not just through one person or through one entity. Because it's divided up into hundreds and thousands of different servers, then there is no one person who's in control. So if Apache said, you know what, we don't like somightcounseling.com and we refuse to host it anymore, and we're not letting our servers do it. Okay, so then a different server somewhere else will pick it up. Like no one person is the owner of it. You can see actually, let's see, you can see a global DNS checker. Here, DNS check propagation tool. This is just, well,
Hannah wrote that she's been waiting to join the meeting, so she hasn't been able to get on.
okay. Thank you for messaging. Thank you for saying something, because I did not see. I see she messaged me in Slack. Okay. Thank you for saying something. If you see someone who's waiting to join the meeting, for some reason I can't turn that off. I wanted to turn it off, but I don't think I can. Because like Zoom has a security feature that either I can put a waiting room, which sometimes it doesn't pop up like, hey, someone joined, or I can put a password. I don't know what's easier for you. If I would rather have a password, that's fine. And I can turn off the meeting room. So maybe let me know what you guys think is easier. Maybe we could do a password, and then everyone will know it, and then we won't have that happen again. But Hannah, I apologize you were not let in.
No worries, thanks. Maybe can we have a password?
Well, yeah, I think we'll do a password. I think that'll probably be an easier way to do it.
Yeah, because sometimes in the middle it turns off and goes back
turns
on,
off and
even it's useful.
I don't get a notification that someone's waiting, so okay.
Thank you.
So we will set a password for next time, and then I'll share it, and then we won't have this issue.
Thanks.
Sure. Okay, so this is a DNS check propagation. So if I own a website and I make a DNS change, this is just a sampling of servers all around the globe that are from different companies. This one's owned by Google, this one's owned by OpenDNS, AT&T, Sprint, Fortinet. I mean, every country, hundreds of countries, and this is just a sampling. I mean, there's tens of thousands of them spread all around the world that all have copies of DNS. So if one of these guys, Sprint, says, I'm not going to host your site, I'm kicking it off, well, it will still be on every other single DNS, right? So I think that sort of answers your question, that the internet is not controlled by one person. It's controlled by tens of thousands of companies, people, nonprofits, organizations, governments, and then you can't just really kick someone off like that, right? Okay. So, all right. So
Thank
yeah, we
you.
spoke. Okay, good. I'm happy that I answered. So we spoke about Wix. GoDaddy, we did not speak about. GoDaddy is a hosting provider. Okay. What is a hosting provider? What is the difference? I just want to make clear again. What is the difference between Wix and GoDaddy and Apache? Right? These are 3 layers over here. They were put like this on purpose. What is the difference between them? So Apache or an Nginx, this bottom layer, doesn't make a difference, is the actual server itself. So somewhere in the world, we have a piece of hardware with little chips and stuff inside of it, right? Semiconductors, that is a server. Call it with an S for server. Now, somebody owns this. You could own your own, you could, I don't know, rent it from Google, you could put it in the cloud, whatever. Someone owns this physical server. Now, I buy a domain, right? A domain is a name, that's a URL, Summit Counseling. So who am I buying that from? I don't buy it from Apache. Apache is just the hardware, right? It's like my computer is a Lenovo, but it's running Microsoft Windows. So the computer is the hardware it belongs to or was built by Lenovo, but they don't own the operating system. The software that's on the computer is Windows. The same thing over here. Apache is just the hardware of the server. It is a server somewhere that just serves, gets data, sends data. Then you have to buy a domain. So domain, there's a list of, I don't know, hundreds of what's called domain registrars. And this is actually regulated. Not everyone can be a domain registrar. This is actually regulated by, I think it's called, let's see, IWC, I think, Domain Registrar. Okay, GoDaddy, MailChimp, Shopify, Only Domain. I mean, there's hundreds of them. I think it's run by a company called, actually, it's not a company, IW3, I think, something like that. Something like IW3, I don't know what it's called. That they are, it's not IW3, it's something, WW3.
Sorry to disturb again, but
Yeah.
Moti Rabinowitz is also in the waiting room. Is it possible
Thank
you
you
could
for
ask him?
disturbing. Yes, thank you for disturbing. If that happens, please disturb me. And yeah, like I said, next week we'll have a password and that will not be a problem. Hi, Mati. I was just saying that basically there's a problem sometimes. People join and I don't see that there's a notification, but Zoom mandates that there's a security feature, at least one security feature, either a waiting room or a password. And we're going to change it to password next week because sometimes if I don't see, then you're waiting and then someone has to message me. So it's easier to do a password. So next week, there's not going to be a waiting room, but there will be a password that I'll share in Slack. And then we have mitigated this issue. Okay, so yeah, we're speaking about domain registrars. And there's hundreds of them. I can't remember the name of the one. There's one organization that manages who can be a domain registrar, meaning if I want to be a domain registrar, I cannot. Maybe I can apply, but they will not accept me. There's a limited number of companies. They have to be, I don't know, real companies of a certain size or something in order to be a domain registrar. GoDaddy is one of them, and you can buy a domain from GoDaddy. So that means if I go to GoDaddy.com and let's use Namecheap. If I go to, that's another one, I like Namecheap because they're cheap. And if I go to Namecheap.com, then I can pick a website. So I want to make a website called My Awesome Website. And let's see if someone took that already, which I assume someone did. So My Awesome Website, oh wow, it's available for $3,500. What does that mean? It means someone bought it and is reselling it. That's what it means. Because websites should not cost that much money. They should cost like, I don't know, $10 or something. But I could buy myawesomewebsite.org for only $9. And I could buy, you know, all of these names have not been taken. Mywebsite.xyz for $6,500. So Namecheap is a domain registrar and they are selling a domain. Now, when they sell the domain, that means, and I buy it, that means that it's now going to get entered into DNS. They are going to propagate their DNS server with, hey, someone bought myawesomewebsite.com. Here's its IP, and it's been bought now. So now we have a correlation between IP and a website, and we're going to take it off for sale. So we can call that sort of like the second layer. There's a server, but then I need to buy a domain. Now, my domain has to be hosted somewhere because otherwise it's not going to be accessible. I need my domain to be accessible to people on the web. It needs to be that when you type in myawesomewebsite.com, it goes to myawesomewebsite.com. So the website, I'm gonna call this name. The name of my website has to be accessible on top of a server, which will have an IP address. Right? We know that really things are referenced by IP addresses. We just use names because it's easier. It's more human readable to use names. But when computers do things, it's with IPs. That's why we have DNS, which is to correlate the names to the IPs so that humans are able to type something that makes sense, like my awesome website, instead of, was that 192.168? Was that 192.167? I don't remember. And then we all get lost. So that's why we have names. That's why we have DNS. So now I have a server with an IP. It's accessible to the internet. On top of that server is I registered a name with GoDaddy, and GoDaddy puts that name on top of the server. Now, usually there's going to be some type of like correlation between who I bought it from and where it lives. Like GoDaddy probably owns this server. That's why I bought it from GoDaddy. It's ending up on a GoDaddy server. That's true most of the case. You can change things around, but standard is when you buy a website, it's probably hosted on the place you bought it from. And again, not all the time, but most website sales companies like GoDaddy will try to get you to pay for hosting too. You don't have to. Like I bought a website recently. I bought it from Google because it was like $12 from Google, but the hosting was cheaper somewhere else. So it's hosted on a different server. Yeah, so it doesn't have to be, but just for simplicity's sake, let's keep it like that. And then we have Wix. So what's Wix? So Wix is this. Wix is the code that we saw makes up the website. I'll make that a square. The Wix level is I point Wix, I make an account with Wix, right? And I tell Wix, okay, I own myawesomewebsite.com, and that lives at GoDaddy's server, and I give them the IP of that, and I point it towards there, right? And then Wix, using Wix, I can make what's called the front end. I can make the way the website appears to the end user. This, okay, that's actually a very excellent time to make this distinction. Here is the massive line between front end and back end. Front end is what Wix does, which is the way the website will look. All these search bars and buttons and images and all that stuff that goes to the end user is called front end. The server with all the code on the server, right? Because there's code on the server too. When you tell the server, please, you tell Amazon, add something to my cart, right? So then it gets added to the cart. How did that happen? Well, the server is running code that says when someone clicks this button and it gets added to cart and I get a request, I'm going to add it to cart and I'm going to return, please check out in the next buttons, right? So that's happening on the server and it's getting returned to the client. So this is the difference between what we call front end. I'm going to abbreviate that as FE, which is the way the website looks to the end user. Everything has to do with appearance. And then we have back end, which I'm going to put as BE, which is everything that the server is doing that you don't see, but it goes on in the background, and then it gets returned to you to the front end. So Wix is used for manipulating front end, making things graphics, visuals, search bars, and all that type of stuff. All this code that we saw over here, right? And we went to SOMAcounseling.com, and we inspected. Okay, ignore the mess over here. Yeah, all this code, let me put this on the bottom. There we go. Okay, all this code is front end code, right? There's no back end code going. This is all things that appear on the front end that are visual. Now, by the way, we can actually change this. One second, let me actually clear all of my drawings over here. Before I clear this, is this clear? The difference I'm trying to make between a server, which is back end, we have name registration, and then Wix, which is like the graphics and the visuals, which is front end. Is that clear? Should I go over that again? Should I say that a little differently? How you guys understand that?
The code is on the front end.
Correct. This code that we see, there is code on both ends, but the code that we see right now in the browser is front end.
And the server is storing all like the memory of what the a website needs to know for the client for the future, or like for the next step.
Yes, Sophia, yes. Like you said, for the next step. So let's give an example of let's say I have a website that has my user data. So it has my age, right? It has my age, my height, and my address, let's just say, right? And it's displaying that to me. So that's front end code. I see it big displayed right over here. But then I say, oh, I moved. I changed my address. So I fill in something and I type, I change my address. Now I live in blah, 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 submit. So when I submitted, now the server took that back end and said, oh, he changed his address. So now we know the next time he comes, we're going to show him the new updated address, right? So that was a back end change. Now, the next time I go to the site, it's going to give me my new and updated address in the front end, right? Because it's going to display it to me, my new updated address, right? So yes, the way you described it is perfect.
Thank you. And then another
it goes-
question. Cookies are, I guess, part of the back end. Like,
Did
do
you
you know
say-
when the
did
computer
you
says
say
it's storing
cookies?
cookies?
Yeah, cookies are stored on the back end. Well, sort of. We'll get into cookies. Cookies, yeah, for simplicity's sake, cookies are generated and stored on the back end. We didn't speak out of cookies. We will soon, but yeah, cookies are back end. You can see them on the front end, meaning you have to have a cookie here. I don't have it in there, but I have it over here. Let's see if this site gives cookies. Yeah, lots of them. These are cookies, right? I don't no idea what they do, but doesn't make a difference here. I think GA is Google Analytics. So this is a cookie that just tells Google that I visited this site. Why? So Google can sell me advertisements, right? Because that's what they do. If you ever notice, like if you Google for something, like, I don't know, awesome vacation in Madagascar, then like 2 hours later, or even 20 minutes later, you'll start getting advertisements on the side of your browser for vacations in Madagascar. Why? Because of this, because of a Google Analytics cookie. Google knows what you search, it knows what website you went to, and then it'll serve you advertisements for it. So I see this on the front end, right? It's right over here, I see it. It's actually in my browser itself. We can find it over here by going to storage and clicking on cookies. Here are all the cookies that Somat Counseling gave me, right? So this is, it's accessible on the front end. I could change this, right? Look, I just erased it now, and now I can type whatever I feel like typing over here. So it's accessible on the front end, but they are stored on the back end so that when the front end makes a request, the back end can validate it that it's really from that person. Now, if that was a little confusing, we'll get into cookies like soon. But yeah, does that answer your question?
Yeah, thank you.
Okay, so I'm going to erase this. All right, now, so I just wanted to show something for a second. When we speak about front end, here, watch this. So we have this about. I'm going to click over here on the left side, this little clicker over here, and I'm going to select that. So now I know where it is in the code, over here. And I'm going to edit it. And instead of about, I'm going to make it say CyberWise is awesome. And now look what the website says. It says CyberWise is awesome. Now, what just happened? Did I change their website? No. If you go to this site on a different browser or even a different browser tab, then you will see about us, right? But in this tab, it says CyberWise is awesome. What happened? The answer is I changed the client side code. I did not change the back end code. I changed the front end. This is front end. This is manipulated. I can manipulate this and make it say whatever I want. But obviously, that's not going to make a difference on the server. If it would be, that would be a massive problem that anyone can do anything, right? On any website. So when I change this, it looks great, right? But it's actually not really the code that's on the back end. I changed it on the front end. The proof for that is going to the same website in a different browser tab says about us instead of CyberWise is awesome. I think so. I think that illustrates the point, the difference between front end code that I can access and I can change, and back end code, which is stored in the server and that I cannot change. All right.
So actually the front end is the client side.
Yes. Client side, front end are synonyms. It's the same thing.
Okay. And the server side.
Server
What is
side,
that?
server side and back end are the same thing. Yeah. Client side, front end versus server side, back end. You can either call it, basically the same thing. Client, server, or front end, back end. It's the same.
Okay. Thank you.
All right. So now let's speak about the actual HTTP protocol and URLs. So now, all right, who's providing that? Servers. Elio asked, oh, 1 second, clear, okay. Elio asked, who's providing the IP for servers? Your ISP, yeah. There is a list. Every server has one IP that they configure, and ISPs, like your internet service providers, have like these big lists of sort of like DNS of which IP correlates to which server. There's protocols called BGP, which is used for like the communications between like massive ISPs. So like when Bezeq in Israel will talk to Verizon, because let's say I want to access a website in America, so that will be hosted. Let's say the original like company that put that up on the web, let's say is Verizon, right? Because it has to start from somewhere, and then Bezeq wants to get it, so Bezeq will like talk to Verizon and say, where's this IP, where's this domain? And these large massive companies communicate, and there's a special protocol for that called BGP. It stands for Borderline Gate Protocol, I think, Border Gate Protocol, something like that. So yes, the ISP does do that. Okay. All right, so now, whoa, what just happened to the slides? There we go. Okay, so now we have a few different components that make up a URL. We have the protocol, which is HTTPS. That stands for Hypertext Transport Protocol, HTTP. Hypertext Transport Protocol, which is transporting hypertext. Hypertext is like HTML, like any text that's special. Like it has code things in it that make it, it adds color. We'll see some HTML soon, but that is hypertext, and it is a protocol for transporting that, and S stands for secure. So this is our protocol, and we can have a few different protocols. That could be FTP, it could be, there's a few different POP3, there's a few different protocols, SSH, and we have our host name. So this is our name of our website we're trying to get to. Then we have a port, right? We learned about, did you ever cover ports before? Spoke about Windows or Linux, anyone cover ports? Yeah, okay, good.
Yeah.
All right, awesome. So port 80 is the standard web port. Whenever you have something running on a website, it is 9 times out of 10 on port 80 and port 443. Port 80 is for unencrypted. It's actually this should, if you're going to be on HTTPS, it's usually going to be on 443, not 80. If you're on HTTP, then it's going to be on 80. So 80 and 443 are the web ports. That doesn't need to be 80 and 443, by the way. It could be any port you want. Just that's the standard. And then we have the path. So the path is going to be, I want to go to filmaccounting.com on this port because that's where it is. If I do 0.81, it's not going to work. It has to be the right port. Courses-cyber, that's the path that I want to get to. That's like the resource that I'm trying to access, the specific resource I'm trying to access. And then a query string. So the query string is delineated with a question mark. You have a question mark and a URL. That means that we are now passing parameters. We're done with the location of the resource. This is the location. That's it. filmaccounting.com, courses, cyber. That's the location of the resource. But now I can ask for a query and parameters. I can say order in ascending order. So it'll give me ascending alphabetically. I can say and filter no photo. So it'll only give me things without a photo. You'll see this in Amazon. You could sort by price, right? So that will be like with a question mark, and then obey like price equals DESC for like descending or whatever it is. So that's not the path of the resource you're accessing. That is the query that you are passing to modify the way the browser or the way the server actually returns that data. And if you want to see an example of that, because I like examples, well, we should be able to see that on I don't know, any site. Let's go to I don't have it here. Say career counseling. So yeah, we see that. Do we have any parameters here? Don't see anything where it's the contact. Okay. Here, this contact, this little hashtag, that's sort of a parameter. It tells you a location on the page. Like if you notice, let's say here I am at the top of the page, right? I'm at the top of the page, but then I enter. Actually, that did not work, so let's actually click. Where did I see that again? I don't even know where I went. Contact, there we go. So I'm at the top of the page, I click contact, it now drops me down to the bottom of the page because a hashtag and then a name references a specific point on the page. This is client side, by the way. So I could be anywhere else. And again, if I click over here, it will put me down there. That's a hashtag. We didn't cover that in the slides, but that's something you'll see.
But there's no port here in the code.
So you don't need a port because by default, it defaults to 80 and 443. So what this is doing is really looking, it's really doing this. And then whatever the path is. You don't need to put that because by default, it'll do that. Sometimes you'll have like a website, maybe they put on a different port for security, like they don't want it on 443. So they'll put it on like some random high port, like 65,000, whatever. And then if you'll need to provide their proper port, but 90% of the time you don't need to. If I actually go to a different port, like let's say I try going to 1, 2, 3, 4, 5, I expect this not to work. And it looks like it's just loading and loading and loading because this website is not on port 1, 2, 3, 4, 5. It's on port 80 and port 443. So 443 will work, right? And 80 will work. Both of them are going to work. Well, okay, this tells me that if you go to 80, it's not secure because it's not HTTPS, because it's no longer S, it's just going to be regular HTTP. And there we go, now it works. Even though it says S, I think what happened is it's redirecting you back to S with 443. Let's take a second to clarify what is the difference between HTTP and HTTPS. There's actually a slide about that over here, but let's clarify it now just because we're there. HTTP is not encrypted. That means that if I go to an HTTP website here, it redirects you to HTTPS. It doesn't even let you go to HTTP. But here's an example of an HTTP only site, HTTP. It's called neverssl.com. And you'll see not secure. And what is this site? This site is a site that will never use encryption, no authentication, nothing. It is a HTTP regular site. And you'll see browsers actually throw warnings like, hey, this is not secure. You sure you want to go here? Right? Big red thing. Your connection to the site is not secure. What does that mean it's not secure? It means it's not encrypted. It means that if I have my computer here and I am transmitting data to the website, which we'll say, let's say it's in the cloud over here, right? So my website's up here somewhere. And then we have a bad guy in the middle, right? He's listening in the middle. That could be like Wi-Fi. I'm connected to his Wi-Fi. Or I don't know, he puts a malware on my computer or whatever it is. So he will be able to read whatever gets sent between my computer and this website. It is plain text. It is English. That is because it's using HTTP. That's why it says it's not secure, meaning it's not encrypted and someone in the middle can theoretically read it. When you have HTTPS, then basically what happens is all data you send gets encapsulated in an encrypted tunnel. So all data is sent through this tunnel and it is encrypted. Someone from the outside will no longer be able to read that data. Even if he does intercept it, it looks like complete, it's unreadable, it's encrypted. It's just a random string of letters and characters and numbers without any meaning whatsoever. That's because the connection between these websites and the host is encrypted. Maybe you've seen on WhatsApp, I think like it pops up that WhatsApp has end-to-end encryption. What does that mean? It means that no one is able to read your WhatsApp messages. And actually in WhatsApp's case, it's actually not like this. In WhatsApp's case, it actually looks more like this. If we have a phone over here, and we have a phone over here, and we have WhatsApp is the server right in the middle, the encrypted tunnel actually goes like this. WhatsApp doesn't even understand what you're doing. WhatsApp just forwards the tunnel from one phone to another phone, but it's never actually decrypted on WhatsApp servers. So data is flowing from one phone to the other phone via WhatsApp, because WhatsApp needs to provide the servers and the cloud infrastructure to do that. But the client is not being decrypted, the data is not being decrypted by WhatsApp. It is being decrypted by the other phone. So from the moment it leaves phone A to the moment it gets to phone B, the data is encrypted. That's what it means, end-to-end encryption. Whereas let's say this example where I'm talking to a website, well, the website is decrypting my data, because if it doesn't, it's not going to function. If I'm talking to Amazon.com and I'm trying to buy something, but I'm only using the encrypted version of the product that I want to buy, then how is Amazon supposed to know what product I want to buy, right? It's encrypted. So when you buy from a website or you're talking to the website does decrypt the data that you send it. But in the case of WhatsApp, this is called end-to-end. They call it E2E encryption, which is end-to-end. The data never gets decrypted from the moment it leaves one phone to the moment it gets to phone number 2. Okay, so now for a website, if you're doing, like we said, HTTP, you'll get this warning, not secure, because someone in the middle is able to read it. If you do HTTPS, then the data is encrypted between your computer and the cloud and the server and the website, and then someone else will not be able to read it. That's the difference. And we'll have a slide about this, and it's actually in the homework too. But that is the difference for now. Is there any questions on that?
Why would anyone choose HTTP if it's not encrypted?
The answer is there is no reason to, at least today. Historically, the reason was that it used to be when computers were very, very low power, like low memory, encryption took up a lot of memory. So imagine you have, it was more applicable by like what's called IoT devices, like mobile things. So let's even take a mobile phone, right? When you have like a mobile phone from like the year like 2000, that's running, 2 megabytes of RAM, and it's a very small device with a very low powered processor. So to encrypt every bit of data that that phone receives and sends would drain the battery, it would cause delays, right? Because the things are very low powered. So they said, okay, let's just do it HTTP so we don't have to deal with the power that takes to do encryption. As now that sacrificed security. Yeah, so there's a trade-off between usability and security. As technology progressed and devices became more powerful, and even small, tiny devices like little sensors, like little temperature sensors that are on, machinery and small, low-power devices like that, those devices are now better and more equipped to handle something that like encryption, which is resource intensive. And therefore, the mitigation was made to HTTPS. And today, there's probably no reason to use HTTP. Probably, I don't want to say that 100%, there's probably one, let's call it 99% of the time, you're not going to use HTTP. Maybe if you have something like, I don't know, if you're managing, do you know what IoT devices are? Like little devices, like you have, I don't know, you have temperature sensors on every machine, like you make, I don't know, you make trains or you make cars. So every car has a sensor that reports to, I don't know, Tesla if the car is overheating or not, just as an example, right? So there's, 10 million of these sensors all around the world. So maybe to manage encryption for 10 million different things, that might be a little complicated, and you can't really update them easily because it's not like, maybe they're not really connected to the internet so often, whatever. So maybe in some edge cases, you'll have HTTP used, but 99% of the time, there's no reason to use HTTP.
Got it.
Okay. All right. So here.
So who decoded the data once it reached its destination? Like, is it the server?
Sorry, again?
If the data are encrypted, like, right?
Yeah.
Who's decoded it once it reached the destination?
The
Is it
server, the server and the client share a key, right? Which is the way encryption works. So the server has the key to decrypt it, and the client also has the key to decrypt it. And both client and server are constantly encrypting and decrypting data and then sending it to each other. Before you have a HTTPS transfer that takes place, before that, you actually have what's called an HTTP handshake, where basically the server and client talk to each other and they generate a key together. So the client says, okay, I want to use this encryption mechanism, whatever. I want to use TLS 2.0, and I'm going to generate my private key based on this public key. And the server will respond, okay, I'm okay with that. I can do that. And I'm generating my private key based on this public key. And they exchange, and then they agree, okay, we're using this, and then they can start sending. That was a really high level, the way I just explained that. For a more like drilled down version of how does that work, because encryption is like super complicated. There's some good YouTube videos on how encryption and like that handshake actually works, and at what exact stage does the client agree to this, and what exact stage does the server agree to that. But the high level overview is that there's an agreement between the client, which is your browser, and the server, which is the website, what encryption to use and how to encrypt it, and then how to decrypt it.
Thank you.
Yes. All right. So, okay. So yeah, we spoke about this. We spoke about domain names as an identifier that defines something on the internet, and that is unique. That's why it's called the universal record locator, URL, right? It is unique universally. And we spoke about registrars that manage these things like GoDaddy or Namecheap. And okay, we have, now let's speak about TLDs, which is top level domains. There are more than 1,500. I showed that for a second when we went to namecheap.com, how when I put in my awesome site, I can buy myawesomesite.xyz.io.info.co.bio.pro, blah, 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 blah. It goes on and on. Explore 400 additional extensions. Like, okay, it goes on forever. Apparently there's 1,500 of them. They actually added some new ones like a week ago or 2 weeks ago. .zip, which hasn't been taken. Let's see. Okay, no, I could buy it. I could buy myawesomesite.zip for $13. That was actually added like a week or 2 weeks ago. .zip and .mov was also added about 2 weeks ago. And that's also available. Google put out one called .gg, which is also available. So yeah, the list, there's also country level domains, right? So we have, let's say .co.il is in Israel. That tells you that it is, okay, so Namecheap can't sell it because the only people who could sell co.il is the Israeli company registrar. I forget what it's called, but if you Google in Israel, probably in Hebrew, like how to buy a website in Israel, then there is the Israeli, I don't know, Misrad or whatever, Office of Selling Domains, whatever they call it in Israel. And those are the guys who sell for .co.il. And the same thing for South America has a South Africa has a .za, which is sold by a specific registrar in South Africa. So yeah, countries, every country has their own top level domain, TLD, and there are over 1,500 of them. So it's a little confusing though, because that means that you could have Amazon.com and then you could have Amazon.co, which looks like com, right? So you have to be careful. Now, in that case, many times large companies will actually buy up websites that are similar to what they have. So let's say I can go to apple.com. I don't know if Apple does this, I'm just guessing. Let's say I go to apple.com, right? So that will go to apple.com. Now, let's say I go to apple.co. Let's see, yeah, that redirects to apple.com because apple.com, applebot.co, because they don't want their brand to be impersonated and someone make a phishing site on CO. So they might have done the same thing for, I don't know, apple.org. I don't know, let's see. Many times large companies will buy up, okay, so apple.org doesn't connect. Maybe they did buy it and they're just not redirecting it. Many times large companies will buy up all the domains that are similar to their site to prevent this type of thing. Like I'm bet that if I put in a second L, right, APPLLE.com, this will direct to Apple. Yeah, it does. Right, because Apple owns Apple with 2 L's, right? So okay, you have to be a little careful to look at the TLDs on a website just to make sure it's the right one. Large companies try to stop this, but small companies don't exactly have the budget for buying up like, I don't know, 100 websites that are all similar spellings and similar TLDs to what they own. So just be careful with that, know it exists. And then we have subdomains. Subdomains, we'll give an example of. Let's actually, yeah, let's use Apple, why not? If I go to store, let's see if Apple does this. No, Apple doesn't do it. Google does it. Let's go to maps.google.com, right? So what's going on over here? .com, let's go backwards. .com is the TLD, that's a top level domain. I'm going to a .com, not a .org, not a .co.il, right? I'm going to a .com. Then I'm going to google.com. Okay, so that specifically refers to a specific website, google.com, the one where you can put in search terms. But now I'm going to a subdomain. I'm going to maps.google.com. So when I go there, it doesn't bring up the search bar, like where you search google.com like this, right? It brings up this. Why? It's because this exists on a different subdomain. You can take one domain like google.com and you can put subdomains, like I have maps.google.com. We can have, I don't know, classroom.google.com. You can have, you know, no limit to how many things you could put. Actually, there is a limit, but let's just say you could put a lot of things under google.com by making a different subdomain. And that is Ki'ilu. It's sort of like a different website. Here I have docs.google.com. So that's sort of like making a different website, while still maintaining the same main website, the same host of Google, and the same top level domain of google.com. So there is a limit of 500 subdomains, but most people do not have 500 subdomains, so you're probably not going to run out of them anytime soon. Oh, by the way, I'm going to show you something interesting, and this is useful. I use this all the time when doing like web penetration testing. I just have to remember what it's called. I'm blanking on it. Right, security trails. Security trails. And this is cool. You can see this on a lot of websites. I've actually found some interesting things on websites just by using this. So let's put in Tesla is the classic example that whenever you use for demonstrating hacking, you always use Tesla. So Tesla.com has 739 subdomains on it. So by the way, this is the website, Security Trails. I'll put that in Slack just because it's cool and everyone can play around with it. Because why not? And on Tesla.com, so we can see like some IP addresses of like where their servers are. We could see some technology. It's running Akamai. Akamai is a DNS, is a CDN, content delivery. And so specifically, I want to focus on subdomains. So these are all their subdomains: IR, shop, forums, beta, 3, engage. There's a lot of them. There's 739 of them. I don't know what they all are, but yeah, they have a lot of things online, Tesla. So you can see any website subdomain just by going to securitytrails.com and then putting them in here. So yeah, that's something cool I want to demonstrate. As an aside, another tangent is there's people called bug bounty hunters, and bug bounty hunters, their job is to basically find vulnerabilities in websites. So Tesla has a bug bounty program on a website called HackerOne, and Tesla will say like, okay, you could find anything, anything under Tesla.com. They'll say something like, you could find anything at star.tesla.com, right? So star.tesla.com means any subdomain of tesla.com. So then like a bug bounty hunter will be like, okay, they're not giving me a list. They didn't show me all 739 subdomains. They just said anything. A star is called a wildcard. It told me anything at tesla.com you can hack and you can find vulnerabilities. But how do I know what subdomains exist? So that's why they turn to something like Security Trails or other websites or other tools. And this will give you a list of a lot, 739. Okay, you have to log in to see more, but yes, a lot of subdomains for Tesla.com.
So we just said subdomains are limited to 500.
It looks like I would assume that Tesla has something special. Maybe their servers don't have that limitation. Let's Google that. I would assume that 500 is probably like your default, but obviously Tesla is such a massive company, they can do whatever they want. Maybe their servers don't have that. How many? Let's see, limit to subdomains. Maximum number. Okay, 500. Maybe that will be for GoDaddy and something like this. Okay, let's see. Yeah. Bind allows this. Microsoft says it could have 20,000. It seems like the default for like smaller things like GoDaddy that are running on like standard technology would be 500, but it seems like if in theory you could go up if need be, and it looks like Tesla did.
Got it, thanks.
Okay, so yeah, all right, so it's 6:40. So let's take a break. Let's take a 15-minute break. And then we'll continue, and then we'll take a dinner break a little later. All right, so let's be back. Let's call it 6:40. Okay, so let's be back at 6:55. Okay. Any questions before we leave on break? No, we're good. Okay, so we'll see everyone at 6:55. Thank you, Shira, for mentioning that. Okay, for the recording that just started, we're going to go through what I just said the past 5 minutes and reiterate over it again. We have an HTTP protocol basic. This is a packet. This is a HTTP request. In the HTTP request, we are doing 3 things. We are doing a get. This is called a method. We are getting something. That means we are asking for it. Like in a cafe, you're going and you're asking the waiter, please get me a coffee. That is what you are doing. You are getting. What are you getting? You're getting the slash. That means the root directory. That means just the basic website, not like any fancy page in the website, just the website homepage. And then you're getting it from the host. And the host over here is going to be google.com. So these 3 components and these 2 lines is what makes up the HTTP request. That's the most important part. The other headers over here are also important, but a little less so. The user agent is what's making the request. So here it's Firefox. If you'd be on Apple, it'll say iOS something. If you'll be on Android, it'll say you're on Android. If you're using Chrome, it'll say Chrome. If you're using curl, like the command line, it'll say curl. So this is who's making the request. Accept language is I'm telling the server, please return it to me in English. I do not want it in Chinese. And here it's even saying English US. So I want it in American English. I do not want it in British English, if there be any difference. And encoding is websites return data actually encoded, like sort of compressed. You know how like when you have a zip file on your computer, right? You can take a bunch of pictures and you put them in a folder, and that folder, let's say, weighs 10 megabytes. But when you zip that, that folder will now only weigh in at 5 megabytes. So you've taken the data, same data, and just compressed it. Websites do the same thing. Servers want to send as little data as possible. So when servers send responses, they will take all the code, right? And then they will compress it down as small as it can go, and then they'll send it. So the accept encoding tells the server what type of encoding my browser knows how to decode. So it's saying, hey, I know gzip and I know deflate. Really, today, browsers are pretty compatible with like a lot of different encodings. So if you like take this header out, it will probably still work. You know, it's probably not going to break. Again, I say probably because I don't want to say 100% of the time. It's not 100% of the time, but most times on a large website that's well engineered, this will work. If I take this out on google.com, it should probably work fine because Google is a very well engineered site. The next 2 headers, cache control and pragma, are basically, these are the same thing, actually, even though they're different. The difference is cache control is used in HTTP 1.0. Pragma is what you call it in 1.1. But to maintain what's called backwards compatibility, which means that, let's say I'm talking to a server that's only 1.0, right? And I pass it the wrong header, so now it's going to crash, and it doesn't know what I'm talking about. So just for compatibility's sake, we use both of them, cache control and pragma, even though you see the value is the same, no cache. What that means, what this no cache means, again, these are the same thing. I'm going to put it like this. What this means is that you're requesting from the server a fresh copy of the data. So like if there's any server in the middle, sometimes you'll have a server that's called a cache server. And what this does is this server, let's give a geographic illustration. If my laptop is in Israel and the website I'm asking is in the US, okay, well, roughly halfway between Israel and the US is the UK, right? Sort of. Let's just say, yeah, it's in the middle before you cross the Atlantic to get to America. So we can have a cache server in England that is caching a value of the site that's really hosted in America. So now this header is saying no cache. I don't want the version that's stored on a cache server closest to me. I want a fresh version, a new version of the website from the actual server itself, located wherever that's located. So that's what these headers are. Again, to summarize, the most important headers is the top two lines. Get, which is your method. There's other methods. There's a method called post. There's a method called head. There's a method called delete. And then guess what that's for? Delete is for deleting things, right? So there's other methods. And then the host and this slash is what you're requesting. Why would you ever want with cache? It's faster. If I'm requesting something that doesn't change so much, like for example, SoulmateCounseling.com, it probably didn't change from last hour to this hour, right? Amazon may have changed, prices changed, right? So I don't want the old one, I want the new one because that'll give me accurate pricing. But SoulmateCounseling.com probably did not change from last hour to this hour, so I may as well request the cache. All right.
How often does the cache get updated?
It depends. I don't think there's a single answer to that. It's however it's configured.
Who updates the cache?
The cache server will basically, the cache server will be in communication with, okay, there's also, before I answer your question, there's also two types of caches. There's a browser cache and a caching server. So like if you're reading about this, and it says cache, sometimes it's not clear if it's talking about the browser cache or the caching server. The caching server is a server. It is between your computer and the real server that's hosting. So there has to be some type of communication between the caching server and this server. How often that takes place, I don't know. It'll be configurable. Let's just say it's every 5 minutes. Let's just say. That means that every 5 minutes, this server will go here, request a copy of the web page, and it'll either say, oh, that's new, I'll update my cache. Or it'll say, nah, that's the same thing I already have. So I'm not going to change my cache. That's going to happen every 5 minutes. And then whatever computer from all around the world is hitting this cache server will be provided with the cache website. Now, that's a caching server. I just want to explain, your browser actually does the same thing. Inside of your browser, there is also a cache. So inside of your computer itself, in your browser, there is a cache. And this also, and I think this is configured from the server, the browser will either yes cache things, it'll be told by the server like this is okay to cache, or it will not cache things. And the server can tell the browser what to do. We'll see servers respond with headers that can say, you're allowed to cache, Mr. Browser, or please don't cache, browser. Caching by the browser is usually used for, let's say, things like images. Like when I go to google.com, or I was like, I'll go to amazon.com, right? The Amazon logo doesn't change. So the same logo it was yesterday is probably the same logo that they have today. So like, you know, on like the top left side of the page where they have their logo, that's not changing. That's an image. So I can cache that image in my browser, right? So therefore I can save my browser some time when it goes to Amazon, doesn't need to re-request every single image. That is saved in the browser. That is different than a server. But the concept is the same thing. The concept is something that is not the server, not the main server, storing data so it's faster. Either it's stored locally in your browser or it's stored in a server that's geographically closer to you. It's the same concept.
Thank you.
Of course.
Can you cache something can something be cached in multiple locations so that it's like spread out more?
Yes. That is basically, yeah, that'll happen a lot. You will have the main server, and in every region will have a different cache of the main thing. We spoke about CDNs before. Remember, content delivery networks, how a large company like Google or Microsoft or whatever will have servers in all different regions or all different countries. A lot of those will be really caching data that is really stored in like a main server somewhere else. And then they're communicating with the main server, every X amount of minutes. But yes, the same thing can be cached in multiple locations. And oh, right, we forgot to talk about connection. Okay, so this is just identifying a little blown up. These are the main points, like we said. Method. Method is what you are doing. You're getting something. This is what you are trying to get. You're getting the root page. This HTTP is going to tell you what version to use. It can be 1.0, 1.1, 2, there's even 3. Host is where you're getting it from, google.com. User agent. User agent could actually be used, let's say a lot of times it's used in metrics. So like I, as a website, I'm google.com, right? I want to know, well, how many people are accessing my website from a computer and how many are using a mobile device? Because, if let's say I have 2 different versions of my site, like one mobile version and one like desktop version or something like that. So I want to know the metrics of how many people are on desktop, how many people are on mobile. I want to make sure it's compatible with different browsers. So like we're all using, okay, Firefox is common, Edge is common, and Chrome is common. But let's say someone's using this random browser that like 1%, 0.1% of people use. And I want to make sure my website's compatible with that, right? So I'm going to see the user agent. Oh, they're using, they're using random browser, right? So I'm going to make sure that my website will support that random browser. So user agent is also important for like gauging metrics and things like that. And then connection at the end tells the server to close the connection after this request. There's a request, I'm asking for something, the server gives it back to me, I'm done. We are now no longer talking. If I want to ask for something else, that is a new conversation. So it's important to understand that HTTP is not a conversation like me and you would have a dialogue. It's sort of like, it's like Googling something. It is, I Google something, it's not ChatGPT, let's put it that way. It's not interactive, it's not a conversation back and forth. It's like Googling something. You ask a question, it gives you what you looked for, done. The next time you want to ask, okay, you can ask again, give me something else. It'll give it to you again, done. There is no open communication that stays open between HTTP requests. And that's indicated by this connection close. Okay, any questions? All right. So now that was a request to google.com. So now let's look at a response. Thank you. Thank you, Mati. Again, sorry, Yehuda, I apologize. Yeah, next week we're gonna have a fix for this waiting room issue so that people will not get cut out when they drop and then they have to come back in. I don't see it. Okay, so now we're going to speak about responses. Sure. So this is a response. Again, just I'm going to go over just Yehuda. This is we are speaking about requests. You're sending to google.com. You're getting, it means you're asking from google.com. Here's the host, that's who you're talking to. And you're getting the home page, which is referenced by this /. Now, Google is going to respond to you with this. So there's going to be headers, right? These are new headers. Date, expires, server, cookies are going to be set. It tells you the content length, how long is the data that I'm returning to you. So there's a lot of different headers that will now appear. And the client is going to interpret this response. So the client gets back an HTML document with all this code, right? None of this is really intelligible to us. I mean, you could read it, it's English, but I don't actually see the website, right? My browser takes all of this code and constructs from it the website so we can actually see it. And I had demonstrated that before with the Toma counseling site, where we look at the code and we can actually change in the code and we can see that reflected in the actual site itself. So now a few things over here. The server is also going to send a status code. Look at the very first line. HTTP 1.1, okay, because remember we requested that, remember? HTTP 1.1, okay. So the server says back, okay, I got that, HTTP 1.1. 200, okay. What does that mean? 200 okay means the request went through. It means everything is fine. We're going to see there's different categories of errors that could be. There's 200 responses, there's 300. This, instead of saying 200, it'll say 300. It might say 400, and it might say 500. So those are actually the only ones that'll say. It's either, oops, I did not mean to make a 1. It's either 200, or it's going to be 300, or 400, or 500. Now, there are other things in the 200 range. So it'll be like 201, and that'll mean something. 202, and that'll mean something. 203. There's 401s, 403s, 404s, 503s. There are different numbers inside of this range, but these, it's either 200 something, 300 something, 400 something, or 500 something. And that tells you just quickly off the bat what happened with the response. Is this what I wanted to see, or did something go wrong? So here we have 200 okay. That means this is what I want to see. We are good. Nothing happened. That is bad. And this is what I expect to see, and we're all good to continue. So now I just want to focus on another header over here, server. You'll notice we have a server header, and the server header has a value GWS, which stands for Google Web Server. And that's telling me that this site, google.com, is running on a Google web server. We spoke about Apache or Nginx. Google's not going to use those because Google is big enough to develop their own servers. Apache and Nginx are commonly used by people who are not as big as Google, but Google has the Google web server, which they built themselves. And then we also have set cookies. In this case, I don't know what these cookies do. They might be tracking cookies. So like Google knows like what you clicked on, so they can give you advertisements. Maybe you're logging into something, so then it'll be an authentication cookie. So like this will really mean, it'll really mean Aaron Liebert. It'll really mean my name, and this is my way of identifying myself to the server. And then it'll have a length of how long it is, and then here is where, whoops. Here is where the actual data, the response data starts. Notice we have a line between this, there's a space, right? There has to be that space between content length, which is the end of the headers, and this, which is the beginning of the body. And remember, we saw that right over here in this slide. We have the headers, we have space, and then we have the body, right? That's exactly what's going on over here.
So what's an example of where the numbers mean something different, like with 200 or 300, 400? What's the difference between them?
So the difference, so that's actually listed right over here. Next slide, right over here. So 200 is going to be okay. 3XX is going to be a redirect. Why is it 3XX? Because sometimes it could be a 301, sometimes a 302. It's 30 something. The reasons why it might be a 301 versus 302 are like very, very particular, and it doesn't really make that much of a difference and whatever. But basically anything in the 300 class is going to be a redirect. A redirect means that it's not here, go somewhere else. So if I go to website A, right? So here's my computer, and I go to website A. Like let's say I go to HTTP, right? Not HTTPS, HTTP google.com. So Google will say, oh, you're looking for HTTP, but we don't have that. Really, you should look over here. And then it'll put me to HTTPS. So at this point right over here, this is a redirect. It says, don't go here, go here. That happens with a 302 response. It'll redirect me to somewhere else. So that's a 302 or a 301 or a 30 something. Let's just call it. A 400 something is a client error. That means that we can't find what you're looking for. The client has made a mistake. So this is, you'll commonly see this. I'm sure you've all seen this. Maybe you didn't notice, but now you'll notice. If you request something that doesn't exist, you will get a 404 error. If I go to someonecounseling.com, right? And then at the end, I say, I want to take me to my awesome course, which it's an awesome course, but that's not the way it's called in the website. So we get, oh, 404, page not found. So what does this 404 mean? It means that the client error, the client has made a mistake. And what's the mistake you've made? You've requested something that doesn't exist. There is no page that is named My Awesome Course, right? So you, the client, have made the mistake of requesting something that does not exist. There's other types of 400 errors. So a 404 does not exist, right? So it does not exist. Let's call it X, right? A 403 means that it does exist, but you are not allowed to go there. So let's say I go to a page called admin, right? And the admin page is only accessible, let's as an example, it's only accessible if you're located in a specific IP, right? So only if your IP address is from New York. Anyone else who tries going to this page, admin, will get a 403. You are not allowed to. Why? Whatever reason, in my example is because you're not in New York. It could be a million different reasons, but something is blocking you. So that is a client-side error. You, the client, are not allowed to go to this page. There's also a 401, which is similar to a 403. Again, it's basically the same thing. It just means something is blocking you. You're not allowed to get there. And there's others, there's 405, there's other different, all these things have, I'm not sure how many of them are. Most of the ones you're going to see are 404, 401, 403, 302. A handful of them you'll see frequently. And then there's like, I don't know, crazy edge cases like a 421, which I don't remember what it is anymore, but you'll see, sometimes you'll see like some really random ones. But most of the time, you're going to see a 404 when the page does not exist, a 401 or a 403 if you're not allowed to go there, and thus the 400 class. And then the 500 class is when there's a server error. And that'll be something like, let's say the server is down. Like there's too many people going to the website. So the server just can't keep up. Then the server will just throw a 500 or a 505. And all that means is that the server is down. There's something server side that's blocking it, not client side. Nothing you as a client could do about that. It's not your issue, it's the server's issue. And whoever maintains the server is going to need to take care of that. So yeah, so these are our status codes. And yeah, these are the common ones. There's more than them. You could Google around for a list. There's a lot of them actually, but these are our classic ones: 401, 403, 404, and 500. Okay. And if you pay attention on websites, you might actually, you'll see these. Like what I just showed before was an example of 404. I can't think of an example of where I know there will be a 403. I don't know where that will be. But let's say you go to, I don't know, let's try some counseling. We could try some counseling, and we could try something like admin. Oops, I missed the slash. Okay, that's a 404. I don't know where we will find them, but you do find them. You would find something where you're not allowed to go, and that will show you a 403 or a 401, not a 404.
Where can you see all these details?
So these pictures are taken from a tool called Burp. that you will all learn to use because it's a great tool for testing web applications. But we can actually see them, either the page will tell you itself, like here it does, but you can actually see them in here in the browser tools. So if you watch over here, look, there's nothing here, right? It's blank. When I go to, let's say, admin, right? Watch, we see a request to admin, and the response is 404. Now, if we click on this, this is actually going to show us everything we just learned about. Here's my, let's view it. Oh, I like this. This is everything we just learned about. We have the request URL, the method is get, and then it's telling me back it's a 404. I think this is Edge. In Firefox, it actually looks a little better. So let me 1 second. I think it's Firefox looks actually nicer. Okay, 1 second. Let's go to admin. Okay, there's our get request to admin. Here's our, okay, it's not showing me the request. There, that's what I wanted to show. I wanted to toggle it to raw. Does this look familiar? All right, this is exactly what we just saw. This is the response. It's responding with HTTP 404, not found, right? Doesn't exist. So here's where we can see it. It's giving me a date. It's giving me, I don't know, some cookie value. It's telling me a server. It's running this Soma Counseling is running on Pepiaka 1.19.10. Okay. And it's giving me a bunch of information. So this should look familiar. This is exactly what we just saw. Now, this is the response. Now let's look at the request. I know it's a little small, I apologize. I don't know if I could blow up this text. Oh, it's like I can, awesome. There we go. Second. Okay. This is exactly what we're talking about. Here's the example of a get. I am getting admin using HTTP2 from this host, somacounseling.com. Here's my user agent because I'm on Mozilla Firefox, so it's Mozilla 5.0. And I accept text and I can take images. Here you're telling it what you're allowed to view. I'm allowed to view images. I'm allowed to view different formats of data. I want it in English. Okay, here's a cookie value, fine. It's gonna respond with me, okay, 404 not found. Sorry, we don't have this. If I go to something that does exist, so let's just click, make this a little smaller. Let's just go to the main page and then we'll go to something else. Here, let's click about. So I want to finally load. You'll see there's a million requests being done. Let's click on testimonials. And I'll have to find that in here. Main page, we are in there somewhere. I actually don't see it. There's too many things. Let's click job placement. You see a lot of Wix things are loading because a lot of things Wix is actually pulling from its backend because Wix has a lot of things on its backend, but somewhere in here we should see what I just did. Let's sort the domain. Wix, storage. A lot of Wix things. Here we go. Soma Counseling. Okay, so let's take this one. So here we are going to view that raw and raw. We are getting somacounseling.com with this, right? Which is the main page, HTTP3, and it responds with 200 OK. because it understands what I did and it's okay and everything's good and it returns it, right? So here's where you could see it in the actual browser tools. Many times you'll see it in the GUI also because the web developers have put something that says, hey, 404, you didn't make it to something, but you can see it in browser tools, and when we do Burp, you will be able to see it in Burp Suite as well. Okay. Oh, so yeah, this is exactly the next slide. We just jumped ahead, but yeah, this is exactly what we just did. You can fire up your developer tools, which is, and everyone can try it now. You open any browser and just right click. Any browser at all does not make a difference. Right click and inspect. The hotkey will make a difference, like how to do it from the keyboard, but right click and inspect will open up this. Elements is the code. And network, you'll be able to see the actual requests going back and forth. And okay, call it different things in different browsers. It looks in Edge, it's called application. You'll be able to see like cookies. So like here's, let's see if I have any cookies. Yeah, here's some cookies. So you can play around with these things. Here's security, it's using HTTPS, it's a certificate, it's encrypted. It's encrypted using, okay, AES 128 GCM. Okay, so that's an encryption mechanism, fine. So using browser tools is pretty cool to learn about websites and what's going on in the back end. And yeah, okay, what time is it now? 7:34. So let's see how many slides we have left. 19 of 35. Okay, so we are more than halfway done. Speak about that. I think it's 7:35 in Israel. So let's take a dinner break. Let's come back in about, okay, let's call it 30 minutes. So let's come back at 8:05 and continue. Everyone is invited, if you would like to, if you already ate or if you are not hungry, go to a website, any website you want, and play around in the developer tools and see what you can see. You can see code. You could change the code, right? Remember, I changed the code on the page to say something else. So change the code. You can look at the network and you could see the actual requests that are going back and forth. And you can look at if you have any cookies. And yeah, play around. So, okay, we'll take a break and we'll come back at 8:05.
Is there anything we shouldn't do while we're playing around?
No. You're playing around server, you're playing around client side. So the worst thing that will happen is you log yourself out of a website and then you'll refresh the page and then you'll log in again. So no, there's no
Okay,
problem.
thanks.
Sure.
Amazing.
All right, so we'll see everyone at 8:05. The browser, in theory, the browser and the server could decide on a really bad encryption algorithm that could be like hacked and broken and decrypted easily. In theory, in reality, that doesn't happen. And the browser says, let's use this, and the server says, okay, let's use this, and they find common ground between them, and that's what they use to create the encryption. So like, there's no one like on top, like in charge of. There's no boss of the browser and boss of the server that tells them what they need to do. The browser and the server are doing this mutually. I mean, Elio, did that like address your question? Okay. All right, any other web questions before we jump back in? Okay. All right, let's get ready. So we're going to speak about HTTPS, which we've touched on before, but we're going to speak about it a little more again. So HTTP, like we said, usually defaults to TCP port 80, right? And it is a clear text protocol that could be intercepted. If there is someone in the middle, what we call a man in the middle, between your browser and the server, they are able to read that data. An example of that would be, let's say, a malicious Wi-Fi. You log into the airport Wi-Fi, right? But it's really not the airport Wi-Fi. It's really some hacker who's just making a Wi-Fi hotspot, and you log into him and you access an HTTP website. Then that guy who is in the middle of your website and you is able to see all data that goes through. If you use HTTPS, which is defaults to TCP port 443, or HTTP over SSL, which is practically the same thing. It's HTTP inside of another layer, but basically it's the same thing. Yeah, it is the same thing actually. It is just HTTP over SSL is HTTPS, which is the SSL, which actually stands for secure, but SSL also stands for S. TLS has an S in it. It really stands for secure, but they all have S's. So that's HTTPS. And that is a cryptographic protocol. The point of cryptography, and really all cryptography really, is to provide what we call CIA, not the organization in America, but CIA stands for confidentiality, integrity, and authentication. So now let's talk about for a second, how does encryption provide that? And by the way, this CIA, the confidentiality, integrity, and authentication is not just unique to, let's say, HTTPS. All encryption really provides that. It provides a level of confidentiality. I don't know what, me as an attacker or as an outsider cannot read the data, right? I don't know what it says. So that is confidentiality. I don't know what it says, it's encrypted. It's integrity. It is, I can't tamper with it because I don't even know what it reads, right? It's not like I could change a transaction, let's say a bill from saying $50 to $500 because I don't even know which letters is the unencrypted equivalent of $50, right? So it's going to provide integrity because I can't change it. And then by extension, it's also going to provide authentication, which is we know that the data is authentic and we know who sent it because only you are the one who have your key, right? I don't have your key. The attacker doesn't have your private key. Only you have your private key. So if you're sending me data and it decrypts nicely and it comes out nicely and it makes sense, it's not like all garbled, that authenticates that you are the one who sent me that data, right? So those are the three things that encryption in general accomplishes. And specifically over here in HTTPS, it accomplishes the same thing as well. So now it becomes harder for an attacker to sniff application layer communication because it is encrypted. There are attacks where you can like force a downgrade of HTTPS to HTTP, and then really you can still sniff the traffic. But browsers, have protections against those attacks. So we try to fix those attacks or any vulnerability that leads to those attacks. So in all information security, it's important never to say the word impossible because nothing is impossible. So that's why we have the word harder. It is harder to sniff communication. I don't want to say it's impossible because nothing is ever impossible. And in authentication also, yeah, identify real identity of a party. That's like authentication. You'll see, I've seen this. I don't do it, but I've seen it. There's people who sign their emails with a cryptographic key. So you can know that the email is really from them. I don't do that because whatever, I don't really care. Like, doesn't make a difference to me. But I've seen it by, let's say, people who run like hacking groups, like black hat hacking groups, like the illegal ones, who like the FBI wants to get them arrested, like those guys. When they like post something to like their social, like their dark web or something, they'll sign it with their key, so that no one knows it's, so that people know it's not an impersonator, because like there's guys trying to impersonate them. Maybe even the good guys, like maybe even the FBI is trying to impersonate a black hat hacker so they can phish people or they can get people to send data or whatever. So people who like really care about privacy will actually use cryptographic signatures in even emails or like posts to Telegram and stuff. So you can identify that it's really them that signed it and not someone else. So it does, cryptography can be used to identify the real identity of a person. Something very important to notice, and I think this is overlooked and many people don't know it. So we're going to know it. We're going to learn it right now. The fact that a website is encrypted, that means the fact that a website is using HTTPS and sending data inside of a cryptographic tunnel, like we said, does not mean that the website is quote unquote safe. It does not mean that there is no protection for web application flaws. It does not mean it is a safe website you can trust with your credit card data. It does not mean that there's no vulnerability there, that some hacker infiltrated the server and sees every, I don't know, keystroke that you type, right? It does not mean the website is safe. Rather, it refers to one particular protection. The website cannot, or not cannot, but the website probably cannot be intercepted by a man in the middle. That is the only thing that it actually means. Many people do not realize that. I mean, if you go to a website like this one, so you have a little lock and connection is secure, and like in some browsers, like I think in Chrome, like this thing turns green and it's like secure, right? That's like, oh wow, it's a good website. It has a lock and it has secure, and it's issued by a trusted authority. That means it's a good website. No, that's not true at all. I've set up many phishing websites, like in the course of my work, for phishing targets at clients. And the first thing I do is make a website and make sure you get this. Make sure you set up TLS so that you have a little lock and it's green and it says secure. And instead of going to the HTTP version, like when you go to this, you get like not secure with a warning. And in some browsers, this is like red or yellow and it looks all scary, right? So the difference between not secure and secure only means one thing. Can someone in the middle read information? That's all it means. It does not mean the website is not a phishing site. It does not mean the website you can trust it with credit card data. It does not mean the website has not been hacked. Nothing. It just means that if someone is in the middle, like you're on a rogue Wi-Fi, like you're in the airport or something, it means it's encrypted. That's the only thing it means. I just want to make that very clear because that is a common, very common misconception. Okay, any questions? No? Okay. So now someone mentioned what about cookies before, earlier in class. So now we're going to talk about cookies and we're going to talk about sessions. So everyone likes cookies. If you live in Europe, then all these websites, we get in Israel. I don't know if you guys get in America, I'm not sure, but in Israel we get it. Every website you go has this big banner at the bottom and you have to click yes, no, and there's like sometimes like 12 different choices. Do I allow this cookie and that cookie and this cookie and that cookie? Yes, no, and it's sort of annoying. That is because of a regulation called GDPR, which is in the European Union, that basically said you have to ask people's permission before you put cookies in their browser. So what are cookies? So we mentioned before that HTTP is a stateless protocol. What does a stateless protocol mean? It means that the client sends a request to the server, give me something. Let's say, let's use a shopping cart. Give me my cart, okay? And then the server responds back, okay, here's your cart, and your cart has item 1, item 2, and item 3 inside. This was a give and a take, right? It is a request and a response. And that is the end of this conversation. Big line. The next conversation, when I ask for my cart again, because I updated something or I changed the quantity, the server has no idea what is in my cart, meaning the HTTP protocol does not support what we call a state. It is stateless. There is no state. A state means like the expression a state of affairs. What is a state of affairs? It's the way things are, right? My state of affairs is that I have an apple and a pomegranate in my cart. That is the state of my cart, right? So HTTP by itself is stateless. it does not save the state of each request. That means the next request has no idea what happened in the previous request, none whatsoever. That's what it means. State is not retained between different HTTP requests. But now we have a problem. When I'm shopping, well, I want my cart to know what happened last request. If my cart doesn't know what's in it, then I have a really broken shopping application, because then I can't really do anything. Every time I leave the cart and I browse something, or I change the quantity, or I do anything, the cart starts from scratch. It says, well, what's in your cart, right? So clearly we see that we need to invent something that will maintain a state of affairs between the client on one end and the server on the other end. And the thing that was invented that does that is called cookies. Cookies were invented in 1994, and their point is to maintain a state. Cookies is a little bit of text. We saw that when we looked in the browser cache and the tools. Cookies is a little bit of text, pretty small. It could be anywhere from like, I don't know, 20 characters to like 100 characters. It's pretty small. It's not a whole Megillah. And it's stored in the web browser. And it has a certain form. It has a name value form. So it'll be like, let's say, name equals Aaron, because that's the user. And that will tell the server to say, welcome, Aaron, because it knows who I am, right? The point of cookies is, they're used everywhere. They're used in a shopping cart application, like we said, but they're also used authentication. When you log into your Gmail, right, you type the username and password, and then you log in, and then you send an email, and then you can send another email, right? Wait, why don't you have to log in again? Oh, because you have cookies that are saved in your browser. And every single time you talk to Gmail, you are sending what's called an authentication cookie. An authentication cookie is a cookie that is agreed upon between the server and the browser. Now, this represents that you are signed in. I just want to speak about that for a second, because that is super duper important. And authentication cookies, from a security point of view, are the most important type of cookie. So I want to just speak about that for 1 second. Let's talk like this. When you log in, okay? A second. All right. When you log in, so you're a client. Here's my client over here. And I pass my username, right? User. And then I also pass my password, right? That's what's necessary to log into any website in the entire world. What does the server do with this? Like, okay, so now the server says, okay, the username and password, I got it. What happens in the backend? So the first thing that happens in the backend is we have a database. Here's our database. And the server, and here's our server. Okay. The first thing that happens is the server takes the username and password and issues a little check in the database to see if there is such a user and if there is such a password. Okay, if no, right, we have an if-else statement. If yes, then do something. If no, then do something else. So if the username and password does not exist, then the server is going to respond, hey, you made a mistake in the password, or there's no user, maybe reset your password, maybe sign up for an account here, right? Because you don't exist. There is no username and password in the database. But if the database says, yes, there is a username and password, check, it does match, then what the server does is it creates a cookie. And a cookie is a random bit of letters, X, V, F, 1, 5, just for argument's sake. And this server creates a cookie and passes it back to the browser. The next request, now that's one request, right? Remember, every request is separate. So the next request, here's my client. My client is sending again, but now instead of sending the username and password, it's going to send the cookie value. It's going to send XV, XFZ, 1, 5. That's what it's going to send. It's sending the cookie value. And the server who gets that is, again, going to take that, pass it to a database, and now it's going to say, does this cookie exist? Does this cookie represent a valid logged on user? FINAC, yeah, similar, it's the same concept. It's the same concept in the back and forth, that there is back and forth, yes. It's not the exact same concept because FINAC ends, it's, SYN, FINAC, and then it's over. Here, every single request, this is gonna take place. Whatever you do, this will take place thousands of times on the website. If you're going to /cart, right? Let's see, CART, yeah. Then it sends a cookie, and then you're going to go down here. You're going to go to / I don't know, buy or whatever you're going to, yeah. Again, you're going to send your cookie. So your cookie is sent every single time you are doing anything with the server, and it's sent instead of a username and password. And this is the way that the server knows that it's the same person who you're talking to, because it knows this cookie represents me, my username and password. This is called an authentication cookie. Now, with this concept, we can also do the same thing for a cart, like the way a cart cookie would look. Let me just draw a line so we know we're talking about something else. I don't want to erase this yet. I'll use different colors. The way a cart cookie would work is the server is going to give back a cookie. Let's say, I don't know, A2. And what that means is you have 2 apples in your cart. A very oversimplified example, but that's the cookie that the server is going to pass back. So now the client is going to, when the client wants to add something to their cart, they want to add a, let's say they want to add a banana. Let's say B for banana. They're going to send back their cookie of A2, which is their current cart, right? They have 2 apples, and they're going to send back their authentication cookie, right? Because they're logged into the website, and they're going to say, I want to add a banana. Okay, so now the server is going to say, great, you are this guy, you are this authentication cookie. I know who you are, and I know that this guy has a cookie value of A2. He has 2 apples. And now you want a banana? Okay, so now I'm going to change your cookie to A2B1. Now you have 2 apples and 1 banana in your cart, and that gets passed back to the client. So this is a way how we can maintain state. We can create something that is the state of something, the state of how my cart looks, for example, in our case, because HTTP itself does not do that. And this is why they had to event cookies. Any questions on that? For sure, this solution got some questions, right?
Yeah, what does every website have an authentication cookie? Like, so you can sign on and go shopping somewhere and not have to put in a username and password.
Usually when you check out, you do, right? So at some
Right,
point,
but let's say tell them, so let's say you're adding to your cart with, and they don't have an authentication cookie
no,
to use it.
authentication cookies are only used when you pass the username and password. Some websites will let you check out without an account. Like, I don't know, whatever, maybe you could do that on, I don't know, Nordstrom.com. Maybe they don't make you make an account, right? But Amazon makes you make an account. You can't buy from Amazon without an Amazon account, I think.
But you could use the cart cookie without the authentication cookie,
Correct. They're not
dependent on each other.
dependent on each other. However, there will be some other cookie that identifies you. Instead of an authentication cookie, it'll be a visitor cookie or something, because we need something to identify you, and then we need something to identify your cart, and then we need something to put them together. So there will be some cookie that is unique to you, the visitor, even though it's not technically an authentication cookie, because you never authenticated, you never passed the username and password.
Got it. Thanks.
Okay. Some other points about cookies, if there's no awesome question, Hannah Weiss. That's what we're going to speak about over here. Expiration varies. So a website, actually, we can see this soon. A website actually sets a time. The server, when it responds with a cookie, will actually say, this cookie is only valid for X amount of time. And the browser takes that and respects that. It could be like 5 minutes, it could be like 6 months. It totally depends. You can make it to be like whatever you want. But cookies do have a expiration date, but the expiration date can like vary wildly. That's why maybe you'll have a case where like, let's say you open up an old computer, you haven't signed on in a long time, or you go to a website you haven't been to in forever, like it'll make you log in again. But let's say your Gmail you go to every day doesn't. So like, what's going on? So basically the cookie expired. That's what happened. That's why you will have to log in again. A few points about cookies is cookies are valid for one origin. That means if I have a cookie, it is only good for Amazon.com. It is not possible to use that cookie on Google.com. Every website issues cookies that are unique to it. It is not possible that it is multi-domain. It is possible to be multi-subdomain. So if I have, let's say, maps.google.com and I have mail.google.com, in theory, that same cookie can work for both domains. That can lead to actually to like security breaches, which is why we have this rule. Scope could be restricted, doesn't have to be, but many times you want to restrict as much as you can, because what would happen if you have, let's say, a website, I don't know, you have a subdomain, you have a subdomain called users.google.com, and then you get a cookie, right? What if that cookie were to be valid on admin.google.com? That would be a problem because you're not supposed to be an admin, you're supposed to be a user. So you can, and many times should, restrict cookies. It's a good thing to do. Not all the time, but it's a good thing to do. Restrict cookies, the scope is referring to a specific subdomain or path. So this cookie allows you to access mail.google.com. It does not allow you to access admin or maps.google.com. Or I could say this cookie allows you to access google.com/user1, but it does not allow you to access /user2, right? You can configure that in the cookie too. That will not work. So there's a lot of things you can do with cookies to restrict them. And the final point that we want to say over here is do not include sensitive data in a cookie, because okay, one second, I'll come back to your question in a second, Shana. Do not include sensitive data in a cookie, because what would happen if cookies sometimes could be, there's certain attacks that could, where you could like steal a person's cookie. So if I steal your cookie, I can log into the website, right? Okay, that's bad. We want to avoid that, because if I steal your cookie, I am you in a way, because this cookie is the only thing that makes you, you, as far as Amazon is concerned. So if I steal this, I am now you. But let's imagine for a second that the cookie was actually your username and password. Like let's say the cookie value the server gave back was like your username and password base64 encoded, or your username and password backwards, right? And that was the cookie. Well, that'd be really bad. That'd be even worse, because if I steal your cookie, I now have access to your username and password. So don't put any data in sensitive data in cookies. Cookies are supposed to be like random, unintelligible strings of letters and numbers. They're not supposed to have any intelligible meaning, because if they do have meaning, like an IP address, or they have meaning like a username, or they have meaning like a password, and they get stolen, then you've just made the problem a lot worse by including that data inside. Hannah, to answer your question, does the server have something like a DNS that issues cookie codes? Good question. It's made randomly. So there's mathematical functions, like we saw in Python, there's random, right? Random returns a random value. So, and the chances of that overlapping are, I don't know, infinitesimally small. That like those types of random generators will make multiple duplicates of each other. It's not impossible, but it's infinite and very small that the random generating things code will actually make doubles. Cookies, we said, are stored in a database. So if the cookie expires after 5 minutes, so then you can clear the database, and now the database is empty, which means you could issue the same cookie for someone else. And that's not a problem, because the cookie is no longer related to user one, now it's related to user two, right? Because it expired, user one logged in, got this cookie over here. He got this cookie over here, then he logged out, or then it timed out and it expired. Then user two logged in, now he gets the same cookie, right? That's not, I mean, that's also very unlikely just because these things are so random. But in theory, that's possible, and it's not that big of a deal because now it represents a different person. It's been cleared from the database, and it's like a new cookie.
Can I ask something?
Yeah, please. What do you want to ask?
Yeah, so from my understanding, it seems like cookies are kind of like a given. They have to be used in most situations. So why are we constantly being asked to accept cookies as if it's like optional?
Excellent question. If you look on any website that offers you that, you will see that they have cookies that you cannot say no to. There are cookies that says like, this cookie is necessary for the site to work. And the example of that would be authentication or a cart. If you don't have that and you say no to that, well, then you can't really use the site. So you don't have an option. The cookies they are asking you about are basically advertisers and tracking cookies, which that's not necessary for you, the user. You don't care. The company, the website cares because that's how they make money. That's how they make money. But you, the user, don't care.
You're saying,
Which means that most of the time you can say no. Like when it says, do you want to allow cookies? No. And you can say no, 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 and the website is going to work absolutely fine. Because you can't say no to the cookies that break the website. Is that clear? Does that answer your question, Chevy?
yes, thank you.
Awesome. Okay, any other questions?
Do phone applications also utilize the same concepts regarding cookies?
What applications?
Like phone applications, mobile?
Yes, yes. They'll use something. Today we use something. Cookies are, like we said, in 1994. Today we use something that's called tokens. You'll see tokens a lot. You can Google for what's the difference between cookies and tokens. They're a little bit different, but it's the same concept. I think mobile apps use tokens more often than cookies. There are a few differences, but they are mostly the same thing and the same concept. Okay. So this is an example of what we just illustrated. Cookies are saved on the server side. When you log into Google, you get a session ID, exactly like we said. When you now request something like your inbox, it knows via your session ID who you are, what you're doing, what email you're in the middle of composing. Like there's so many cookies out there. I mean, even just like going to like any, I don't know, let's go to Amazon for a second. Actually, do my other browser because this browser does not have a cookie. Actually, yeah, we'll do it here. Okay, so we're on Amazon.com and here's my cookies. Okay, lots of session tokens, time. I have no idea what these things even do. Like most of them are not important for like me as like a security perspective. A lot of these are like Amazon things. They want to know, how long you spent on a certain page, or they want to know what you clicked on, or whatever it is. But let's see what other things there are. Okay, there's some storage over here. Storage over here. As you can see, there's a lot of different data. There's a lot of different things. If I were to log into Amazon, then I would get an authentication cookie. And then you'd be able to see that as well here. Right now, I'm not logged in, so you won't see that. But there's tons and tons and tons of data that gets stored in cookies, and that tracks basically everything you do, whether it's adjusting your cart or whether it is saving the email as a draft, right? That will also be saved as a cookie, like what you're working on, a minute ago. So now, a second. A few qualifications for a strong cookie, a good cookie. If you have a cookie that is too short, then that could be like guessed, or that could be brute forced. And then you could have someone log in as you because your cookie is very small. So a strong cookie, strong session ID, we're going to use the words interchangeable, sessions or cookies. The cookie creates the session. Because I have a authentication cookie, now I have a session with the website. So it's similar. It's the same, not the same thing, but because you are passing your authentication cookie, that creates a session. I should, it's like the previous drawings. when you create your username and password, you get back. Remember, the server gave you a value like XBC, right? This is you. This represents your session. And then we had a cart value. Remember, like we had apples 2 and bananas 1. So this represents your session. It's your cart session. So everything you, the client, do, you're going to be referencing these 2 values. Together, that creates a session. So a strong session is going to be valid for a single session. That means that when I log out, right, I close the browser, I log out, then I should be logged out of the website. I should not be able to log out and then like refresh the page and then I'm back in somehow. No, when you log out, your cookie and your session details should be invalidated and they should be erased from the database, and that stops them from being hijacked and being reused by someone else later down the line. They should also be time limited. We want to have expirations. We don't want it that I logged into one site on some computer a year ago, and if you go back to the same site now, I'm still logged in. That would be a little problematic if I'd be leaving my data, my logged in sessions around on every computer I ever went to. That would be a problem as well. And lastly, they should be random, because if they're guessable, if the cookie value is going to be like, my username, so it'll be like Aaron 50. Well, that's pretty guessable because there's probably a guy named Aaron 49 and maybe there's an Aaron 51. So then I can find someone else's session. So they should be random, and you'll see most of the time they're at least 32 characters long. At least they can be longer, but at least they're 32 characters long many times and totally random. Then like this. Okay. Okay. And lastly, let's just mention this. There's what's called local storage and session storage, and these are stored client side. When we look at a browser, we'll see we actually have like cookies. There we go. Let me get rid of this eraser. Okay. When we look in a browser on Amazon over here, we see we have cookies. So like session ID, session token, I don't know, time, skin, whatever that is. And then you also see we have something called local storage, which on Amazon has some other cookies. And you'll see we have something called session storage. There's a few differences between cookies and like session storage. One of the probably the biggest difference, there's a few differences. You can Google it for like the exact breakdown, like a chart that compares them. One difference is size. Cookies, I believe, are shorter. So like cookies have like a maximum value. I don't remember how long it is, but there's a maximum value for a cookie. In session storage, it can like go on forever. You can store like 5 megabytes of data in this one field. You can have like this 10,000 lines long thing value in this field. Oh, by the way, let me just focus. Key value. This is important. This is the name of the cookie, key, and this is the value. Remember we had this in Python by dictionary. Dictionaries use keys and values. So the key is address bar service called, whatever that does. The value is true. The key is CSM previous URL. The value is Amazon.com. Like it's like a dictionary. So now session storage and local storage can be longer than cookies, but the most important difference, and I think we'll speak about this a little bit later, maybe in a few weeks when we speak about web attacks, but is an XSS attack. Does anyone know what an XSS attack is? No? Okay. An XSS we are going to speak about later. That's not the subject for now. I just want to bring it in for 1 second to differentiate between cookies and local storage. An XSS is where an attacker is able to run JavaScript on a website. They found a vulnerability in a website. They're able to run JavaScript on a website and steal cookies. And if you steal a cookie, then like we said, you have stolen that person's identity. If I know the cookie, your authentication cookie for Gmail, then all I have to do is go here, paste your cookie in, refresh the page on Gmail, and now I will be logged into your email. right? It is you. So now if there's a certain vulnerability called an XSS where an attacker is able to steal cookies, cookies can be stolen via XSS. Anything put in session storage, or what's called tokens, cannot be. That is a difference between cookies and, let's say, authentication. Tokens, I'm sorry, I'm sorry, I misspoke. I'm not referring to an XSS, I'm referring to a CSRF attack. I'm sorry, a CSRF attack, excuse me. A CSRF attack is a different attack. Yeah, we'll get into that also a little bit later. I don't think this is not the time and place to explain it right now, but I'm sorry, I misspoke. What I just said about XSS is not true. It is CSRF attack that I was referring to. A CSRF attack is only applicable if the authentication is used with cookies, but not with session storage, not with tokens or anything stored in local storage or session storage. Why that is not the subject for now. I could put it in recommended reading about that and about the differences between cookies and tokens and storage and the cookie store. There's lots of good things on Stack Overflow about that, like breaking down the exact differences, but we can leave that for recommended reading. Okay, so before we do this task, are there any questions?
I'm just wondering if that means that Amazon is not using cookies for your shopping cart, because you could log out and come back in and then your stuff is still stored in your shopping cart.
Excellent question. How does that work? I'm going to elaborate on your question. Why is it, if I just said that cookies are supposed to expire, why is it that I can leave open my Gmail and I go there every single day and I never am asked to log in again? Right? Let's elaborate on your question. What you're asking is, something doesn't add up. How is Amazon storing my cart that I can log out and log in again and it's still there? I thought we said that cookies are getting validated after log out. And I'm adding on that question, how is it that Google and Gmail just keeps me in my email? I open the browser, I'm in my Gmail. Close the browser, open again, I'm still there. What's going on? So the answer, I'm going to answer your question first. Amazon is actually persisting your cart server side. So what that means is that when you log into Amazon, so you have created for yourself a user, right? You now, in Amazon's books, I'm going to call you, you are user one. User one browses to a bunch of different things and adds them to a cart, which creates a cart cookie, right? Amazon actually saves that cart cookie for user one in their database, and they actually save it there, the cart cookie. So even though you log out and then you log in again, your cart will still be there. And Amazon does that because it's a matter of convenience. It's annoying for shoppers to have to add the same things over and over again just because they closed the browser accidentally, or they logged out, or it timed out and expired. That'll be annoying. So Amazon actually saves that cookie server side and then sort of recreates it when you log in again. That's the answer to your question. The answer to what I brought up is how by Gmail, you never get logged out unless you don't visit it for a long time, is because there is something called, there's a cookie, right? Which actually, with Gmail, they're called tokens, because again, cookies, tokens, Google it afterwards. That could be homework, but for now, let's just call them the same thing. There is what's called a auth token, which is an authentication token. And then there's what's called a refresh token. So it's hard to draw like that. Okay, refresh token. So the auth token is what we've been talking about till now. It is the token that says who you are. It is the token that if I have this token, again, I'm using the word token and cookie interchangeably right now. If I had this token or this cookie, I can log into your email. It is the only thing that makes you, as far as Gmail is concerned. And this token actually does get invalidated when you, let's say, close the browser. However, This token, the refresh token, does not get invalidated, and this gets stored in your browser's local storage. We saw local storage, if you remember, right, a few minutes ago, right, over here. This is our storage, local storage. So it will be stored here, your refresh token. And when you go back to google.com, when you go back to Gmail, Gmail will say, have you been here before? And your browser will say, yes, I have a refresh token. And it'll pass the refresh token to Gmail. So here we have the same type of server client. Your browser will pass the refresh token to Gmail. Gmail server will respond with, amazing, here is a fresh auth token. So the auth token is actually what makes you logged in. Without an auth token, you can't do anything. But the refresh token is how you get a new auth token without signing in again. If you sign in, if you log out, like you actually click log out, then everything is destroyed. Your auth token is erased, your refresh token is erased, everything is invalidated and erased, and you need to start from scratch with your username and password. But if you don't actually log out, you just like close the browser and come back in a few days, your refresh token will still be there. Your browser will send the refresh token and get a new auth token. So I'm glad you brought that up because I got to ask this question and now we understand more. I wasn't sure if we wanted to go there, but I'm happy that we were able to speak this out. Any questions on what I just said?
Yes. So a refresh token, you can have more than one then, I guess, because on the same thing. So I can have my phone and my computer logged into my Gmail at the same time.
Yes, they will have different
Then
tokens.
would be, and that's stored in the wherever it is in the Gmail.
This local storage. I mean, here, local storage, we see Amazon. That's because I'm on Amazon.com. But yeah, it'll be in the local storage of the browser for Gmail. And even different
And
browsers.
I would see all the tokens that I have
Yes,
connected to that account.
yes.
Thanks.
Even different browsers, like if you access Gmail on Edge and Chrome, that will be two different tokens, two different auth tokens, two different refresh tokens. Every client that accesses the server will be unique. Okay, any other questions about refresh tokens, cookies, auth tokens, authentication in general? How does shopping carts work? Anything? Okay, so we have an exercise. You've used, everyone's used Wireshark before, I think, right? So yeah, no, I think so.
Yeah.
All right, awesome. So use Wireshark and sniff your traffic. So it's a pretty simple task. Boot up Wireshark, go to a browser, take your browser and go to a clear text website, and then go to an encrypted website and see what the difference is. And then you could screenshot it and send me a picture on Slack. An example I'll put in the chat, I'll put in the Slack chat. I'll put in Slack, a good non-encrypted site is called NeverSSL. I'll put that in random. NeverSSL.com. That site is always HTTP. It never will be encrypted. And then any encrypted site is just about like anything else you will find. Google, Amazon, Apple, whatever you want. It'll always be encrypted. Mostly. Again, 99% of the time. So let's do this task. I don't know, let's give 8:53. How many more slides do we have? Let's see. Okay, 26 to 35 are coming along nicely. Let's give I don't know, 15 minutes. 15 minutes, 20 minutes, 15 minutes for this task, okay? So everyone's clear on what to do, just to show the difference between HTTP and HTTPS. I will be here. I'll just turn off my camera, but I will still be here if there's any questions, okay? All right. anyone has any questions, just like ask them, just, speak. Sometimes the Slack chat is, or the Zoom chat is hard to see, it doesn't like pop up, So if you could just ask any questions that you have, just speak them. I'm just putting on a timer for this. Yeah, let's call it 15 minutes. Go. Okay, so if anyone has any questions, I'm here, even though I just turned off my camera, but I am still here for the next 15 minutes, and then we'll continue afterwards. Thank you. 2 people so far sent me things in Slack. They did it. Awesome. Yeah, you see what I'm talking about on the right side, exactly what you highlighted. That is totally jumbled up data. You can't understand a thing. When you do the HTTP, then you will. So yeah, perfect. Thank you, Chaya M, for sending. And yeah, perfect screenshot. You can even see in your screenshot, you see everything we spoke about. You see the get, and you see where it's going, and you see HTTP1, and the request URL, and everything like we said. And that is all clear text. Okay, time is up. That was 15 minutes. I got a few people sending me in Slack. How is everyone else doing? We were able to do this task. We're not able to do this task. How's it going? If it's a matter of a few more minutes, that's fine. We can wait for you. So I only heard from a few people on Slack. Oh, a few people sent me. Awesome. Amazing. Thank you, Mate and Eliyahu. Okay. I got a few people, a bunch of them. Anyone else working on it who would appreciate a few more minutes until we continue, or no? If you like a few minutes, just ask. That's fine. Okay, no one's asking, so I assume that means we're all good. And let's continue. So that means those who did it, and those who did not, did not. So, okay, let's continue. Yeah, we have a few more slides still. Okay, break time. I think in general people would rather finish earlier than break for 15 minutes and come back. I think that's usually the general consensus of people. Okay, say that, don't worry about it. Mati, yes, they both use version 1.1. 1.1 is the most commonly used version. You can actually, I start the recording still going, right? You can actually Google around what is the difference between like 1.1, 1.0, 2.0, 3.0. There's a few like syntax issues, or there's a few differences in the way that the server will like handle things like caching and that type of stuff. But in general, it's the same thing. Like I have never came across something where I was like, oh, this is 1.1 and not 1, and that makes a big difference. Like in general, it's pretty much the same. There are some cases, there are some attacks that are only on HTTP 2.0. Those attacks are rare anyways. So in general, yeah, HTTP and HTTPS will both be using HTTP version 1.1. And the newer sites will be using 2.0 or 3.0. Okay, so let's continue. Awesome. Yeah, we're not going to have a break because let's continue through. That seems to be the consensus, to continue instead of break. So let's continue through. Yeah, let's speak about the cloud. What is the cloud? The cloud is a buzzword. Well, that's not what the cloud is, but that is what it is. The cloud is a buzzword. Everyone knows the cloud this, the cloud that. What is the cloud? I saw there's like a laptop sticker that someone at work has, and it says like, it's like someone like going like, secret, there is no cloud. It is just someone else's computer. And that's sort of true. What is the cloud? The answer is it is someone else's computer. It is Google's computer, or it is Amazon's computer, or it is Microsoft's computer. Instead of you having something on your computer, you are storing it on their computer. Now, their computer is really powerful and it's spread out globally. So it's available at every country in the world, and it's fast, and it has unlimited storage, and et cetera, et cetera, et cetera. But at the end of the day, the cloud is someone else's computer. So now, there's a lot of advantages in cloud. Basically, just some history. 1 second, someone sent me in Slack. Okay, no worries, Shia, don't worry about it. Okay, so the cloud came out. Let's talk about before we had cloud, the old way of doing it. I have a website, and I have to buy my website, and if I want to have my own server, so I have to buy a physical server rack. I have to spend the money on this big clunky rack of servers, and I have to plug it into the wall and pay for the electricity. And if it goes down, then I need to buy a new one. And if it breaks, then I have to hire a technician to come and fix it. And let's say I want to expand my website. You know, I have a lot of data. I now need to buy a second server, right? Now, let's say every server costs me $1,000, okay? So I've already used up this server. It is full of data. So now I need to buy another server. Well, that's another $1,000. But what happens if the only data that I use, you know, I filled up this, right? I had lots of users. My product is super popular. Everyone loves my website and they love my, you know, whatever I'm doing. So I fill up one server. So I buy another one. And then I start filling it up and then meh, people don't like my product anymore. Or the growth is not as fast as I thought it would be. So now I still spent $1,000, but I'm only using 25% of my new capacity, right? But I ended up spending $2,000, even though I'm only using 1.25 of my total capacity, right? So what would happen? This is what people start to think, wait, maybe there's a better way of doing this. What if we can sort of centralize servers instead of every single person having to manage their own server, and not just server, databases, storage, right? Your computer has a hard disk inside that has, I don't know, 250 gigs or 500 gigs, or maybe it's a terabyte, right? Well, you bought a terabyte worth of memory from your laptop company, right? I have a Lenovo ThinkPad. Okay, so my Lenovo ThinkPad, I bought a terabyte of memory. What if I'm not using a terabyte? What if I am only going to really use 100 gigabytes? So why would I pay for a terabyte? Well, the answer is maybe I'm scared. Maybe I will use a terabyte, and then it'll be annoying because I'll have to rip out the hard drive and put a new one in. Okay, but what if there's a better way? What if I can pay as I go, right? What if as I get users, then I have more servers to handle them? What if as I fill up my hard drive with things, my hard drive expands? Well, that's essentially what the cloud offers. The cloud offers servers for running websites, storage for storing things, databases, networking. We spoke about cache servers, right? So, and we spoke about CDNs, right? I want to have a server in Zimbabwe so that people in Africa see my site that's hosted in Hawaii without waiting half a minute for it to get across the globe. So I want to have networking servers in a lot of locations, but I don't want to have to pay for that because that's really expensive. So I'm going to pay a cloud provider to do that for me, and I benefit from it. So there's tons and tons of services. Amazon has like a list. Go on AWS, which is Amazon's cloud. That's AWS, which stands for Amazon Web Services. And they have like, I don't know, 50 different things they offer. Like they offer anything you can think of. Like they have a service that does that. You could like cryptocurrency mine in the cloud. You could do like anything you want can be done in the cloud, and they have a specific service that's like optimized for what you want to do. And this allows you to be faster innovation, right? Because again, imagine my server example. It might take a week for my order from the server company to get shipped to my office, right? By the time I place the order, they have to ship it to Israel, and then they have to send a guy to install it and whatever, right? That takes a week. Well, here on Amazon, I can scale instantly. If I need something, I get it right away. It's flexible. Sometime I decide, you know what, I don't really need all this. Okay, so don't pay for it. You only pay for what you use. Or I decide, you know, I don't really need my website to be available in Australia because I don't have any users there anyways. So I'm going to scale back on where my website is distributed. Okay, so do that. That's fine. As opposed to if I would have had invested in a data center in Australia, and then I realized, oops, I don't have any users in Australia. That would be a colossal waste of money. So the cloud is one simple solution that offers a lot of things to businesses and even to end users like us. Like if I want to store things, I could use Google Drive for storing things. That's the cloud. AWS is the market leader in cloud, and Azure is catching up. I don't remember the numbers, but it's something like, I don't know, AWS is like 40-something% of market share. Azure is like, I don't know, 30% of market share. Google's like 5%, and then like a bunch of other people are like 1, 1, 1, and 1, something like that. AWS is by far the leader, and Azure is number 2. Azure is Microsoft, by the way. AWS is made by Amazon. Azure is made by Microsoft. There is Google Cloud. There is Alibaba Cloud for people in China and other places in the world, but I don't think we use Alibaba Cloud much in the United States because we don't really trust China. And there's also laws about storing data on servers. So like if you're in Europe, you are not allowed to store, like let's say Facebook actually had Facebook was fined a week ago, $1.2 billion, which is an insane amount of money. And what do? They had moved European user data to United States located servers. And that is a very big no-no in the EU because the EU is like really crazy about privacy and all these types of data protection laws, which is why we see those clicky banners everywhere, because that's because of the EU and because of California passed a PPP. But it's mainly really because of the EU, GDPR. So yeah, Facebook was fined $1.2 billion like a week or two ago for this. And that's why we don't use Alibaba Cloud because no one really wants their data stored on Chinese servers unless you're, I guess, in China or in maybe a country that doesn't really care. But most people are using AWS or Azure. They are definitely the global leaders in cloud storage and cloud everything. So now there's 3 different types of cloud, and this is important to know the difference between them because you'll hear people say this. They'll be like, oh, that's a SaaS. And you're like, what is that? And that's a PaaS, and that's a IT. What are we talking about? What is a SaaS? So SaaS stands for Software as a Service. It's SaaS, Software as a Service. And this is what we're all familiar with using. We use Google Drive. Zoom is Software as a Service. It is a piece of software that is free or paid, and it uses the cloud. So when I upload my files to Google Cloud, to Google Drive, or I send an email in Gmail, I am using the cloud, right? I'm not storing it. I'm not paying for the data that's my email is taking, right? Google is. And they give it to me for free, or there's a paid tier. But I am using software that is run and managed by Google, and I have no say in how they use it. If I say, you know, I would really like it if all Gmails, I don't know, some feature in Gmail, I wish I could send emails to 10,000 people at once. Well, if Gmail doesn't allow that, there's nothing I can do about that because I'm using their service. So I have to play by their rules. So here you see you have less control. Zoom, Salesforce, pretty much anything you're going to be using, Dropbox, I don't know, say anything. It's probably software as a service if you're using it as an end user. Now we have other things that is platform as a service. And this is used not so much by end users, but it's used by software developers. And these are like frameworks like Git or GitHub or other companies that do that type of thing, development frameworks. And these are frameworks that are on the cloud. So it's on the internet, it's not local on my computer. But here you can actually build things. You know, you can actually code something. You can work with their platform to do things. You're not limited like an end user of Google Drive who has no options, no say in the matter. The end user, the software as a service, he can use the software and that's all he can do. The platform as a service, you can actually build things on that platform and then do whatever you want with the thing that you built. Okay, so people who use this are really software developers. And then we have infrastructure, which is IaaS, infrastructure as a service. And this is the most control you can get. You can actually own your own server. So if I want to manage my website from beginning to end, I can have a server, a web server on AWS. And this web server is my problem. So if I want to expose it or like put a vulnerability on it and it gets hacked, that's my issue, right? AWS is not going to fix my server. It is my server. It is on their infrastructure, so I pay them for it, but it is my responsibility. That would be different than, let's say, if Gmail gets hacked, that's not my responsibility, that's Google's problem. You know, everyone goes to Google. Google has to fix it. But with infrastructure as a service, there's no guarantees. What you make is your responsibility to fix. It is your responsibility to secure. Okay, there is something called like a SLA, like a service level agreement. between cloud providers and the people who use them, that Google says, okay, we're going to protect your environment from like A, B, and C. We're going to make sure that no one can like brute force the login to your AWS account. Like that's on us. But you need to protect the fact that if you have running a vulnerable server version, that's on you. So like there is a division of responsibility between the providers and the end user. But as we move along this chart, it is more and more control in the end user, like me, the guy who's provisioning it, and also more responsibility. If something goes wrong, it is much more my fault than Google fixing Gmail. Okay. Any questions?
Yeah, what's the IaaS? What exactly are you providing? Like the PaaS is actually providing you with software, I guess, some of it, and then you build on it.
Right.
And IaaS, what are they providing?
They provide you the infrastructure. So if you ever log into AWS, and you can make an account and play around, with 2 clicks of a button, you can make your own server. You click like server, create, done. So how did that work? So it's sitting on their infrastructure, like they connected it to the internet. They gave it an IP address, so I can talk to it. But that server is my responsibility. So if I install a vulnerable server version or I expose some service that should not be exposed to the internet, that's my problem. They're not going to fix that for me. Does that make sense? Like they give me the underlying connectivity to the internet. They give me the underlying storage. So like who actually physically owns the database is them. They're the ones who have 100 terabytes of data that I could use. The actual physical components of it belong to the cloud providers. But basically, beyond the physical, anything built on top of the physical is going to be mine. They're not providing me software even, as opposed to, let's say, platform, where they're providing you some type of software that you can use to build other things. With infrastructure, they give you really nothing, no software, nothing. They're just taking care of the physical aspect of it.
Thank you.
Mm-hmm. Okay. All right. Okay. And let's summarize. Yeah, we did not have any breaks. We had like 1 break today. Let's summarize. What did we cover today? So we spoke about the internet fundamentals. What is the internet? We spoke about how it is millions and tens of millions and hundreds of millions and maybe even billions, I think, of interconnected devices, all sharing data. And we spoke specifically about web. www stands for World Wide Web. That's where all websites live. We spoke about how you access websites using the HTTP protocol, unencrypted, or HTTPS, which is secure and is encrypted. These are the only ways of accessing websites. We mentioned in the beginning, there's other protocols. There is FTP, there is SSH, there is, I don't know, there's a lot. There's more than this. These are common though. These protocols are not for accessing websites. These are protocols for doing something else. So FTP will be used for transferring files between my computer to your computer. SSH will be used for logging in on my terminal to an SSH server. So I can like run commands and I can control the computer, but that's not web. So these are the only ways of accessing websites, HTTP and HTTPS. We spoke about the request and response, client sends, server responds, and this goes back and forth and back and forth and back and forth. And we spoke about how status codes. You can know if something's going wrong and what exactly the issue was by looking in the status code. So instead of just like, hey, it's broken, what happened? Well, you can say, oh, it's a 404. That means that there is no resource, right? I asked for this resource, it does not exist. It's a 404. And oh, it's a 403. They're blocking me. And 200 means it's okay, right? So you can look through, just quick Google. It's worth, a minute or two just to look at all the different status for codes, because I only mentioned the common ones. And we spoke about headers. What is the point of headers? Headers tell the server and browser a lot of information. The client will send headers by saying, this is where I want to go. I want to go to the home, or I want to go to page A, and it'll say what language I take, and it'll say what type of encoding I can use, and it'll pass cookies and authentication headers, and the server is going to respond back. It'll set cookies using headers. It will give other information about what server it's talking and other information using headers. And then we spoke about the body of the request. The body of the request, as we saw, is the actual code itself, not just the headers of I want this page and I speak English. No, it's actually the code itself, which we saw in the example of StoneMikeCounseling.com. I get back a lot of different code in the body, and the browser takes my code. Here's my code. These are the headers. This is the body. And the browser takes my code and interprets it and puts it together into images and into text. And that's what I see when I browse the website. Cookies and sessions we spoke about as well. I highly recommend Googling what is the difference between cookies and sessions, because there are a few nuanced differences. Practically, they both provide authentication and they both provide the creation of a state, because HTTP is stateless. It does not know what you did last request. So your cart's not going to work, and your draft email that you're writing is not going to get saved, and nothing else you do is going to persist into a state unless you have cookies and sessions, which will create that for you. And we spoke about authentication cookies, and then non-authentication. Authentication cookies keep me logged into something, and those are really, really, really sensitive. And then we have something that's not sensitive. It's not authentication cookie. It'll be like, my cart contains 2 apples and 1 banana. That's important for the user experience, that they don't have to have their cart resetting every 10 seconds, but it is not necessarily sensitive. And then lastly, we spoke about cloud models and types. There's different usages of the cloud, like we said, whether it's running servers, whether it's creating database, whether it's storing things online like Google Drive. And we spoke about the different types, whether it's infrastructure as a service, or it's a platform as a service, or it's a SaaS model, which is a software as a service. And it's important to be familiar with these terms. You will definitely hear people use these like, oh, it's a SaaS, and they expect you to know what that is and what that is not. So that is important that you know the difference between these 3 things. All right. Any questions on anything we covered? We covered a lot. This is our first time talking about web, so it's probably new for everyone here. I don't know how much you've exposed this before, so is there anything that's not clear or you want to ask on?
Yeah, would you be able to post something that we could look on, not new information, more to like understand, like, because we never heard of a lot of these things before, so that we could understand this better without even going on to new things.
Yeah, for sure. I can
Thanks.
post some good resources.
Thanks.
Any chance you would be able to go over the Wireshark captures? So I don't know if anyone else is interested, but I'm curious. I wasn't able to see exactly what it was that you were trying to show us. So
Yeah, sure. Let's see. I'm just wondering. I would do it on a virtual machine because I have like a lot of things running in the background that I'll sort of like interrupt. Let's see. Let's try it. Before we do that, let's go over homework. So if anyone's interested, they will stay. And if they're not interested, let's leave. So let's just go over what the homework is, and then we'll do that, okay? What's the difference between get and post? Today, we only spoke about get methods. If you remember, I did mention there's other ones, post, I'll give you a hint. There's one called delete, right? So Google that, figure out what's the difference in post and get. When is one used? When is the other used? And then what are some other methods and when are they used? I also said that we spoke about HTTP 1.1 and 2. I said they're pretty much the same practically, but there are differences and there are vulnerabilities that only exist in 2. There are differences, even though most of the time for the end user it doesn't make a difference, but there are differences. So what is new in HTTP 2? And what is cache used for? That's question number 3. And then the last question is run an FTP server on Kali and sniff the traffic, which is really similar to what we just did with HTTP. But here, let's do it in FTP because we've been speaking about HTTP. HTTP is web. I did mention FTP, SSH, some other things. So let's see how those look. So run an FTP server on Kali and then sniff the traffic with Wireshark. That is the 4th question. And I will, I'll put this, there'll be a new assignment for that as well. For those of you who finished the Python project, awesome. I think so far I got like half the people sent me something. A few other people asked me, hey, it's going great. Can I have a few more days? That's fine as well. If you would like to present your project next week. So presenting your project means showing the code and running it and showing what it does and maybe show a little bit of the code. Not that you have to walk through and explain every line of your code, but demonstrate your product that you built. Why did you build this? What does it do? Does it solve a use case for you? Does it solve a problem for you or something like that? And then, show, I don't know, maybe a little bit of the code. Look at this function that I wrote. This is the main function in my whole program. This is the function that does A, B, and C. And, just show that off. How long would the presentation be? 15 minutes, maybe, not so long. If anyone is interested in doing that, please message me in Slack. You can DM me privately in Slack, and we'll try to schedule that in. As Jonathan said in the beginning of class, presenting skills are like really important. I found that's what sets apart like real professionals who work at large companies and manage large projects for other large companies. Like we're not talking a little company, we're talking a multi-billion-dollar company for another multi-billion-dollar company. The people who do that type of work know how to present things well. They can make their point clearly, concisely, confidently, and it's really a great point to develop. So if you'd like to, please message me, but there's no pressure, but recommended.
Would I have
Alright.
to download, for number 4 of the homework, would I have to download Wireshark onto my VM if Kali's on a VM?
Yeah, that's probably the easiest way of doing it. Just
Okay.
that way you don't get messed up with networking. So yes, easiest. Okay. So that's the end of class. We will go over the Wireshark now quickly. I'll set that up. And yeah, we'll see everyone next week. Any questions? I'm still here while we just set this up.
On the slides in Slack, are you able to re-upload all the first slides because they seem to have disappeared because over 90 days or something like that?
The first slide from like before I took over from Omer.
I'll tell you where from.
I'm looking Linux, Windows, from before virtualization.
Yeah, from
Yeah,
before virtualization, they seem to disappear. From before number 5, yeah.
Yeah, sure. So 1 through 4. Yeah, for sure.
Thanks.
All right. Yeah. Okay. All right. So let's see this Wireshark. I hope it's not too messy on mine because there's like, I have like 100 tabs open and there's a lot of data going through. So let's actually see what's going on. Yeah, we have a lot of stuff going on over here. So, okay, here see if there's anything HTTP. All right, here's, let's do it like this. Okay, 1 second. All right. So I'm going to continue without saving. And I'm going to go to Amazon.com. Great. And now I'm going to go to neverssl.com. Okay, so we went to one encrypted site and one not encrypted site. Let's stop this. And now we need to look through it because there's a lot of data here. Okay, let's actually go from the back. Let's follow the TCP stream. Protocol. Let's see, this is mostly encrypted. All this TLS is encrypted. All right, so I have ARP, I have DNS. I should have some HTTP. Let's see, what's this? Follow TCP stream. This is, oh, not sure that, I don't know what that website is, Microsoft something or other, but this is unencrypted, right? We can see all the data that I'm getting. And we can go, okay, so actually this is a good enough example. This is encrypted, right? I'm following a TCP stream and this is encrypted. Red is client and blue is server. But you see nothing here is intelligible as it's using in encrypted data. Here, again, red is client, blue is server, but it's totally intelligible. That's the difference between HTTP and HTTPS. And as I click through here, we should see most of this is all encrypted, but we should see, so yeah, here's Amazon. Here I am going to Amazon. So I could see a few things. I could see Amazon, I could see HTTP 1.1. Any other useful data? Okay, I can see some names, Whole Foods Market, like Amazon owns that. Some different stuff like that. But most of what I see is totally encrypted and I have no idea what's going on over here. So if I was a man in the middle who was intercepting this on like a malicious Wi-Fi, I would not be able to see what you're buying. I would not be able to see your credit card information. I would not be able to see anything. I'd be able to see you went to Amazon.com. That's basically what I'm able to see, but nothing else. That's when it's encrypted. Now we should see soon. We went to neverssl.com. Should be around here somewhere. Amazon loads a lot of data. Yeah, this is still Amazon. Here we go. And here is what it looks like when we go to neverssl.com. Everything is seen. You can see I'm getting, responding. This is the code. It's giving me this document has been moved to here. Then I go there, and then I get this. Now, actually, part of this is actually looking like it's being encrypted. I'm not sure if this is encrypted or actually encoded. You might be able to just like decode it, because encryption and encoding are not the same thing. Encoding you can undo. Like this is encoded like gzip, right? It's like a file that I zip. That's not encrypted. It's just encoded as a zip file. So if you unzip it, you can see it. So that's or it's actually it's an image. That's why it looks like funny, because it's an image. So anyways, but the point is like you can see all of this data that we did not see when you went to Amazon. And the reason is this is HTTP. It is not using SSL to encrypt it, and Amazon is obviously using HTTPS. All right.